Hello everybody and welcome to Quizmaster. My name's Gary and I'm going to be your primary instructor for this section where we're going to learn all about the UI or user interface. So over in Unity we're going to learn how to add a canvas to our game which we'll use to display things like text and images and also accept player input via things like buttons and sliders. Now everything we learn in this section is going to be really transferable. So in future projects, if you ever need to display a health bar or some score text to the player, you can use these exact same techniques. For our quiz game in particular, we're going to need a way of storing our question data. And for this, we're going to use something called a scriptable object, which is a little bit different to the regular mono behaviors that you've encountered so far. Then once we've got this data stored, we're going to need a way of using this in our normal script. For this, we're going to be using lists and arrays, which are ways of storing collections of the same type of variable. And then to iterate through those collections, we're going to be using something called a for loop. So we've got plenty of work to do for our quiz game, so let's dive right in. Before we go ahead and jump into Unity, let's look at our game design document, because this is really going to keep us on track and keep us focused on the game we're trying to build. And the first stage of this, for me at least, is to understand the concept of the game we're trying to create. Now we're going to be building a quiz game. And for our quiz game, we're going to be getting the player to answer a set number of multiple choice questions. And each question is going to have a limited amount of time to be answered. This will put a little bit of pressure on the player and also prevent them from just going off and Googling the solution. And crucially for our game, it's going to be very UI focused gameplay. So we're not going to be moving characters around the world and worrying about all of that. Instead, we're going to be looking at the UI. So things like text fields, buttons, images, and all of that kind of thing. So with that UI focus in mind, let's have a look at some of the screens that we're going to have to build to make our game run. First off, we're going to have the question screen, and this is going to have a text field where we're going to put the question. We're going to have a number of multiple choice buttons for the player to click on. And we've also got some other stuff that we need to think about. We've got the score up in the top left corner here, so that's going to show how well the player is doing at any given point. We're going to have a timer in the other corner, and this is going to tell the player how long they've got left to answer any given question. Then down at the bottom, we have this long progress bar, and this is going to give the player some kind of indication of how far through the quiz they are. Now, once the player has clicked on one of these answers, we then need to worry about giving them the solution. So that brings us onto our next screen, where we're going to actually repurpose our original question text box and make it a confirmation text box instead. So this will tell the player if they got the answer correct or incorrect. And I think it would be nice if they got it wrong to tell them what the correct answer is. And in that same vein, we're also going to use some highlighting to show the player which answer was correct. Now you may notice that this screen looks incredibly similar to the last, so rather than making an entire new canvas just to show the answers, I actually think it would be a good idea to repurpose the question screen instead. This will make our game much easier to manage, and we can essentially cycle back between question and solution as many times as we like. But once the player has answered all the questions for our quiz, then we are going to need to change things up a bit and go to a win screen or an end screen if you like. Here we're going to tell the player congratulations and give them their final score. And we're also going to give them a button to give them the option to replay. So with all of that in mind, let's go through the game mechanics that we're going to need to build when we jump into Unity. First of all, we're going to need a mechanism to store and retrieve all of our questions. We're going to need buttons so the player can select the right answer. And if we want to put some pressure on the player to answer the question, then we're going to also implement a simple timer. We're going to need a progress bar to show how many questions the player has remaining in the quiz, and we're going to use something known as a slider for that. We'll need a simple scoring system to show the player how well they're doing. And finally, we're going to need a way to restart the game when the quiz ends. Finally, let's ask the three big questions for our game. The first being, what is our player experience going to be? Well, for a quiz game, I'd quite like the player to feel knowledgeable and intelligent. So for my game, I'm going to have a lot of positive affirmation and congratulation messages, but you could also go the other way. You can actually make the player feel less intelligent by berating them for getting answers wrong and generally just being a bit silly with it. So even though it is a quiz game, we don't necessarily have to make the player feel good about themselves. For the core mechanic, it's really going to be a test your knowledge kind of game. So I'm going to be using this as a kind of studying tool, as it were. And finally, our game loop is going to be to answer a set number of questions on a given topic within a set amount of time. So with the game design document all set up, it's now time for a quick challenge. Let us know what your quiz is going to be about. So what topics do you intend to cover? This could be anything from ancient history to pop culture to your favourite band. For my particular game, I'm actually going to go with an educational based quiz, and I'm going to ask questions about Unity and C# to help people study. So once you've come up with the topic for your quiz and written your game design document, please do share it, and I'll see you in the next lecture where we actually jump into Unity and start to build it. So I'll see you there. In this lecture, we're going to learn all about the UI canvas and set up a background image for our game. Okay, so here we are in a brand new Unity 2D project. So if you haven't set that up just yet, go ahead and do that now. You can see in the top here that I've called mine Quizmaster, and I'm using Unity 2021.1.7. I've also gone ahead and renamed my sample scene to Game, and I've imported the sprite pack that's attached to the resources for this lecture. So in here we have a background image for the game, we have a couple of different button images, and we also have the pre-visualization images that you saw in my game design document in the last lecture. So feel free to download those and import them into your own project, or you can go ahead and create your own images, and you can just use these provided ones for a rough idea of the size they need to be, so that you can follow along without any weird scaling issues. Now before we go ahead and add anything else to our project, let's actually discuss what UI is and how a canvas works. So whenever you hear the term UI in game development, this tends to mean user interface. And the user interface includes everything from text boxes, buttons, sliders, menus, mini-maps, and pretty much anything that the user can interact with that isn't part of the game world itself. Now in Unity, the UI elements as they're known live on something called a canvas. Now this canvas generally exists in something called screen space and is mostly separated from the game world, which exists in world space. Because these canvas objects are objects in the hierarchy, we can also have multiple canvases in our game. And this is going to come in really handy for our quiz game because we're going to be separating things like the quiz itself from the background elements so that we can flick between canvases without having to change everything every time we change screen. So if we jump back over into Unity, let's actually have a look at the canvas in a bit more detail. As I mentioned, this is an object that exists in the hierarchy. So to add one, we can go over to our hierarchy area, right click, head down to UI, and then click on Canvas. Now the first thing you might notice is that we have a canvas being added, but we've also had an event system added. Now you don't really have to worry too much about the event system for now. Really, the only thing you need to know at this stage is not to delete it because we are going to be using the event system later on. Now if we click on the canvas and take a look at the inspector, the first thing you'll notice in here is that it doesn't have a standard transform component like every other object you will have encountered so far. Instead, we have something called a rect transform, and this works fairly similar to the standard transform component, so it has a position, a rotation, and a scale. But it also has some extra stuff in there as well, so we have things like the width and height, we have some anchor points and pivot point information. Now in time we'll also get familiar with these other components, so the canvas component, the canvas scaler and the graphics raycaster, but for now we can just leave all of that alone and we'll just come to look at these when we actually need to change things in the future. Now adding just a canvas on its own to our project isn't particularly exciting, and to really see all of it in action we need to add something to that canvas. So we're going to start off with a simple image, and whenever we add stuff to the UI, it has to be a child of the canvas itself. So if we go ahead and right click on the canvas rather than in the general hierarchy area, head down to UI and then click on Image, we'll add an image to our canvas. Now, if we look closely, we can't actually see anything in our camera view here. But if we change over to the game view, then lo and behold, here is our nice big sprite. So why isn't it showing up in our scene view? Well, if we flick back over to scene view, this is the camera view. So this is looking at the world space of our game. But as I mentioned in the earlier slides, the canvas exists in screen space. And you may be able to see this kind of white outline on the edge here. And that's actually the corner of our canvas. So let's double click on our canvas to center it. And you'll notice we zoom all the way out, and down in the bottom left corner, you might still just about be able to see where the camera view is. We can also see that our sprite has now shown up in the center of our canvas area. But even though the canvas is significantly bigger in scene view, in game view, everything comes together with world space behind the camera, and then the screen space being overlaid on top. And to demonstrate this a little bit better, let's also go ahead and add a sprite from our 2D objects, and we'll just add a circle so we can tell the difference. We'll set the position to be, say, 5 on the x-axis and 0 on the y-axis, and we can see our circle here. And then if we click on the canvas image so we can see the difference in position, our position here is at 0, 0. But if we change the x-axis to be 5, so it's the same as the circle, we notice the square only moves ever so slightly. So this can be a little bit confusing when you first encountered the world space and screen space working together. But with a little bit of time and a little bit of practice, then all of this should hopefully become fairly intuitive as we move forward. For now, let's just go ahead and delete our circle sprite because we don't really need it for our game because we're working purely within the UI. So for this project, we're not actually going to have to worry about that kind of difference between screen space and world space. It's just something that I wanted to point out so that you are aware of it. Now, if we head back into scene view so we can work on things a little bit easier and click back on our image, if we scroll in a little bit so we can see what we're doing a bit clearer, and if we head back over to the inspector, we can see that our rect transform now has all of the options open for us to be able to change. So in addition to us being able to change things like the position, the rotation, and the scale, we can also play around with some of these other options. As you might expect, if we change the width of our square, then the width will increase, and the same goes for the height. But notice as well that the X and Y position are also changing. So let's reset that back to 0, and we can see that the sprite gets recentered back on the center of the screen. And that's because this is viewing the center of the screen as the 0 position. This isn't necessarily fixed in stone though, and we can change it based on the anchors for our image. And we can see here that we've got options to set the different anchor points. However, rather than amending the anchors and pivot manually for now, let's actually click on this icon in the top left of the rect transform, this little square with the red cross on it. If we click on this, this will give us some anchor presets that we can use. So if we click on, say, the top left, this will anchor our image to the top left of the screen. And I don't know if you can see this, but we've got this icon here that was previously in the center of our square, but is now locked to the top corner. Our image hasn't actually moved, but if we look at the rect transform behind this window, we can see that our position has changed from 0, 0 to 577 and negative 260. If we set these back to 0, then the center of our image goes to the top left corner. And this brings us onto the pivot point. So our pivot point of our image is currently the center of our sprite. But we can also change this, and we again have some options here that we can play around with. Or we can use the anchor preset option again, and this time let's hold shift to also set the pivot. So holding shift, we notice the icons all change to add this little blue pivot icon. And if we again click on the top left corner, we'll notice again that our position has been changed. And if we set this back to 0, the pivot point is now the top left of our image, and so is the anchor. So it's now anchored the sprite to the top corner of the screen. One final thing we can do in this anchor preset is also set the position by holding down the Alt key. If we hold down the Alt key, we'll notice again that the image is changed to represent the image being moved. And we can actually do both of these things together. So we can set the position and the pivot point by holding Shift and Alt. And let's pick a different option. Let's move it to the top right instead. And if we do that, then notice that the anchor moves, the pivot moves as well, and so does the image. Now, some other great options within these anchor presets are these options around the edge, which will allow us to stretch the image. So if we again hold Shift, Alt, and then click on this top one, we could say stretch the image across the entire top of the screen. And notice how the anchor, which used to be a cross, has now been split down the middle. So we have 2 anchor points on this side and 2 anchor points on this side. And options like this that stretch across the top or bottom of the screen are great for things like menu bars and stuff like that. But for us, we're going to be adding a background image to our canvas. So we're actually going to use this one in the bottom right corner. So if we hold Shift, Alt, and then click on this, it will break the anchors apart again, and it will stretch the image across the entire canvas. And this will be the case regardless of the aspect ratio or resolution that your game is in. And while we're on the subject of resolutions, we could reasonably use these different anchors and pivots and setups to design a game that can work on multiple different resolutions and aspect ratios. But since this is our first foray into the UI and the rect transform, let's actually just design our game with one specific resolution in mind. And that's going to be the most common resolution, which is HD. So over in our game view, let's change from free aspect to full HD 1920 by 1080. And now whenever we look at our game view, we'll always have a good idea of our target resolution. Now let's jump back into our scene view and actually do some work on our game. Now rather than making this the background image for our game, I'm actually going to turn this into a pre-visualization image, which will help us to lay out elements of our game as we move forward. So down in our Sprites folder, I'm going to take the first pre-visualization image that I've got and drag it into the source image. And because I want this to appear on top of everything else and be slightly faded out so we can see behind it, I'm going to change the color, and I'm just going to bring the alpha value down to say around 0.25. And on the canvas itself, I'm going to change the canvas sort order and just increase that up to say 100. All this really means is that it will appear on top of any other canvases that we add with a lower sort order. And finally, I'm going to rename my canvas to the pre-visualization canvas. And that, I think, brings us nicely on to your challenge. I want you to add a second canvas to the hierarchy. And on this second canvas, I want you to add the background image for your game. So you can either use the one that came in the resources or find your own for your particular game. And I want you to make this image stretch to fill the entire screen. So pause the video now and give that a go. Okay, welcome back. So to add a second canvas to our hierarchy, we're going to go over to our hierarchy area, right click, go down to UI, and then select canvas. This will add a second canvas, and I'm going to rename this to the background canvas. Then we're going to right click on our canvas, head down to UI again, and go up to image. We can then make this stretch across the entire screen by going to our anchor presets, holding Shift, Alt, and then selecting this bottom right option. And then finally, we can take our background sprite image and drag that into the source image. If we want to see our background unobscured, then we can just click on our pre-visualization canvas and hide it. And with our canvas all set up, that puts us in a great place for the next lecture, where we're going to start adding some text to our canvas. So I'll see you there. In this lecture, we're going to learn all about TextMeshPro and start adding some text to our canvas. So we're going to start things off by adding a title to our canvas. So on our background canvas, let's right click, head down to UI, and then right at the top, we should find two options. We should have a text and a text TextMeshPro. Now, if you don't see TextMeshPro, then we will have to do a little bit of setup before we can use it. So let's assume that it's not there for now, and instead head up to Window, head down to the Package Manager, and then under Packages, Unity Registry, we want to scroll down until we find the TextMeshPro. Now, if you don't already have TextMeshPro installed, you will have an install button here instead of a remove button. So go ahead and click on that and wait for it to import into your project. And if you're using an older version of TextMeshPro, then you may have an update button there as well. So again, go ahead and click that if you want to update. For me, I'm all up to date and ready to go. So I'm just going to go ahead and close Package Manager. And the next thing we need to do before we can actually use TextMeshPro in our project is just an extra piece of setup. So again, head up to Window. You should now find TextMeshPro in this list. And we want to go to Import TMP Essential Resources. If we click on that, we'll get this Import Package pop-up window. And we don't really have to worry about all the stuff that's in there. Just make sure that everything is selected and then go ahead and hit Import. And this will set things up in the background, and you'll see we have a TextMeshPro folder now in our Assets folder. So with all that set up, let's again go ahead and right-click on our background canvas, head down to UI, and now we should definitely see the TextMeshPro option in this list. Now you may be wondering why we went through all of that trouble when there's already a default text option in here as well. And really, it's because TextMeshPro is a lot more flexible and a lot more usable than the old text system. So to add it to our canvas, let's go ahead and click on that. And we can see that this is dropped in our text element in the middle of our canvas. Now, since this is going to be the title text for our game, let's also go ahead and open up our pre-visualization canvas and re-enable that. And then if we reselect our text and zoom in a bit so we can see where things are going to be placed, what we're first going to need to do is just click and drag that into place. And then resize the text box by just grabbing one of these corner nodes and dragging that open. If you're anything like me and like nice round numbers in your transform, then go ahead and just fix these up. So maybe 750 by around 150. And we're going to have an X position of 0 and a Y position of around 450. And if we then scroll down in the inspector, we'll find the TextMeshPro element that we're actually going to be playing with. And there's a lot of stuff in here, and it could be a little bit overwhelming when you first see it. But if you've ever used a general text editing program, then a lot of these options should be fairly familiar to you. Let's start with the text field, which is currently saying new text. And let's put the name of our game into that field. So you may want to go with Quizmaster, which is the same as the section name, or you might have your own name for your particular quiz. I'm going to go with the name of Quizzical. Now, since this is going to be the title for our game, having the default font is going to be a little bit dull. So the next thing we want to do is to change up the font. But before we can do that, we need a font that we can change to. And that brings us on to a bit of a mini challenge. I want you to do some font shopping. So go online and find a free font that you can use and add it to the assets folder of your project. Now, if you've never looked for any free fonts online before, I've added a couple of links to the resources for you to check out. Now, just be aware that when you're looking up fonts, always double check the usage rights. So these might be free and open source, or they may only be free for personal use. So if you're planning to release your game into the wider world or using things for commercial purposes, then do just make sure that you check the license of the font before including it in your game. So pause the video now and find the perfect font for the title of your game. Okay, welcome back. So while you've been away, I found a font called Prisma. So if we go ahead and click on our text element and head down to the font asset section, if we try and add this font to TextMeshPro at the moment, then we'll notice it's currently missing from our list of available fonts. And that's because TextMeshPro requires something called a font asset. And what we've currently got at the moment is just a standard font file. To turn this into a font asset that TextMeshPro can use, again, we're going to have to head up to Window and then down to TextMeshPro. And then we want to go to the Font Asset Creator. This will bring up this little pop-up box, and there's a whole bunch of settings in here, but the only thing we really need to worry about is the source font file. So let's drag our font into there, and then go ahead and click on Generate Font Atlas. Once this is finished packing, then we'll get a nice output to give us some basic information, and then we can go ahead and hit Save As. I'm just going to save mine as Prisma SDF as it comes in. And we'll see that in our assets folder, we now have the font asset file created for us. So let's go ahead and close the asset creator. And now we can go ahead and just drag that into the font asset on our text element. The next step in getting our title looking good is to resize it and reposition it within our text box. So we can do that with all of the things that you'd come to expect from a text editor. So we can increase the font size. And we can change the alignment options. So I'm just going to go with middle center. Now that's roughly in position. I'm going to go ahead and just hide my pre-visualization canvas so I can get a better look at what I'm doing. Click back on my text object, and then I'm going to look at changing the color of my text. Now we can do that with the vertex color, so we can open up our little color picker and choose a color that we like the look of. But this is actually where TextMeshPro really does come into its own, because underneath this we also have the color gradient, and if we enable this, then we get a whole bunch of extra color options. So for my game, I want to try and match kind of the look and feel of the neon bar that's running around the edge, and I'm going to do that with a vertical gradient, and then I'm going to change the top one to kind of a light blue. Then I'm going to scroll all the way to the bottom of my inspector, where we've got a whole bunch of extra options for TextMeshPro. We can do things like changing the face color, we can add an outline to our text if that's something you want, we can add a drop shadow with this underlay option, and we can also add some lighting and some glow. I'm going to start off with some underlay, and if we zoom right into our text so we can see what's happening with this option, the first thing I want to do is change the color to a kind of bluish off-white. And then let's have a look at some of these other options that are available. We can do things like change the X and Y offset, and this is great for lifting text off of the page a little bit. We have a dilate option, which controls the thickness of that underlay. And we have a softness, which will change it from a hard shadow to a soft shadow. So to try and emulate the glow around our neon light, I'm going to leave the offset at 0, 0. I'm going to leave the softness at 1, and then I'm just going to play around with the dilation options until I get something that I like the look of. If we zoom out to see how that's starting to look, and I think that's not looking too bad. But the other thing I want to add is a glow. So I'm going to click on glow, and it's gone a weird green color. But that's because if we open up this option, we have a very green color attached to it. So again, I'm going to use a slightly bluish white color. And then under here, we have various options. So we have an inner and an outer glow. So if we zoom in again so we can see what's going on, an inner glow will do exactly what it says. It will add a glow to the inside of our text. But I'm going to go with an outer glow to bring that out a little bit. The power controls the strength of that glow, so I'm going to turn that down quite a bit just to give it a nice subtle glow. So zoom out once more, and I think that's not looking too bad. And with my title all set up, I think it's now time for a challenge. I want you to fine-tune your title text, and do feel free to play around with all of the TextMeshPro options to see what you can come up with. I find the best way to get familiar with TextMeshPro is really just to play around with it. If you happen to get into such a state that you break it, you can always just delete it from the hierarchy and try again. Then I want you to go ahead and add another new canvas called Quiz Canvas to the hierarchy. And then on this canvas, add a new TextMeshPro element, which we're going to use to hold the question text for our quiz. So pause the video and give that a go. Okay, welcome back. So hopefully you've now got a title to your game that's looking arguably a lot better than mine is currently. And hopefully you've had a nice play around with TextMeshPro to understand how all the different elements work. The second part of your challenge was to add a new canvas to your hierarchy. So let's go ahead and do that by right-clicking, going to UI and then Canvas. And we're going to call this one the Quiz Canvas. On our quiz canvas, we want a TextMeshPro element. So right click on the canvas, go down to UI and then up to TextMeshPro. And in order to position this, I'm going to re-enable my pre-visualization canvas and then reselect my text element and drag that into position. Let's tidy up some of these numbers so they don't drive me and possibly you insane. And then let's scroll down to our TextMeshPro component, increase the font size a little bit, somewhere maybe around 48 should do. And I'm going to align that to the middle center. Finally, rather than having just new text in this box, I'm going to fill it up with something. So you might want to say, add a dummy question in there maybe, but I'm just going to go with some classic lorem ipsum text. And this is a little bit long, so I'm going to cut that last sentence off. So with that all set in place, let's close the pre-visualization canvas, and our game is starting to take shape. So congratulations if you managed to complete that challenge successfully. And in the next lecture, we're going to start looking at adding some buttons to our game. So I'll see you there. In this lecture, we're going to start adding some buttons to our canvas so that the player has a way of interacting with the game. Okay, so to add some buttons to our canvas, we're going to add them to our quiz canvas. So go ahead and right click on that and then go down to UI. And again, just like we had with text, we have two button options. We have a standard button and a button with TextMeshPro. So let's go ahead and click on the TextMeshPro option. And this will bring a button into our scene. Now, if we scroll in a bit, we'll notice that we can't really see the button. And the reason for this is because our quiz canvas is currently on the same layer as our background canvas. So to fix this, let's go and click on our quiz canvas, head over to the canvas component, and in the sort order, we're just going to increase this to 1. This will bring the button completely into view above the background, and we can now see what we're doing. Now, before we start worrying about the layout of these buttons and things like that, let's actually just investigate what this button is actually doing. So we'll notice that it came in with a child, and that child is the TextMeshPro element, which handles the text that appears on top of the button. On the button itself, it's set up very similarly to a standard UI image. So we have the rect transform, canvas renderer, and image component. But if we scroll down, we also have this button component. If we go through some of the options that are on this component, we have an interactable toggle. So this just allows us to set whether the button is clickable or not. If we deselect this, we'll notice the button gets grayed out. And if we recheck that box, it'll come back to being full white. And that's controlled by these color options here. So we've got a normal color, which is the default color for our button. We've got things for when we've hovered over the button, when we've pressed it or disabled it. We've got some navigation options, which we're not really going to worry about for this section. We're just going to leave that on automatic for now. And we have an event box called onClick at the bottom here. Now this will be where we start adding scripts later on to control what happens when we actually click on those buttons. And because we're going to be controlling these buttons in code later on to, say, highlight the answer to our quiz question, we're not actually going to worry about all of this color tinting options that we have available to us. Instead, what we're going to do is we're just going to go up to the transition drop-down box and change this from color tint, and we're going to click on none. This will drastically simplify our button component and also make it a lot easier to deal with in code. The next step to setting up our button is to give it a better background image. Because we're no longer going to be changing the colors via the button component, what we're instead going to do is just change the source image. So let's find an image for our button, and I'm going to use this neon square blue image that I've brought into my project. And we notice it doesn't look too bad as it's come in, but it does look a bit strange. And to fix this and make it look a little bit nicer, what we're actually going to do is we're going to use a sliced sprite. So down in the image type, we're going to go from simple and select sliced. And this isn't actually going to do anything at the moment because we've got a warning here saying that this image doesn't have a border. Well, to fix this problem, let's head over to the sprite itself in our sprites folder. And we're going to go and head into the sprite editor. And all we're going to do in here is just add a border for our image so that we can stretch and scale it without warping it too much. So down in this box in the bottom right corner, we're going to add a border. And for this image, I think maybe a border of 75 around all edges will do the trick. So we're just going to keep these corners nice and round, but it doesn't really matter if these straight edges get stretched or contracted. Go ahead and hit apply once you've done that and close the sprite editor. And we can see now that the image around our button has changed quite substantially. Now, before we start resizing this and working any more on the button, let's bring up our pre-visualization canvas so we can see where these buttons should go. And rather than resizing our button manually to fill the area that we want, what we're actually going to do is use something called a layout group. So on our quiz canvas, let's right click and just create a normal empty game object. And we're going to call this the answer button group. Let's drag our button into that group so that it's now a child. And then on this empty game object, we're going to go over and add a new component. And we're going to want a layout group. And you can find this in the drop-down menu under layout, or you can just type layout into the search box and this will bring all the options up. Now we have three main options. We can have a grid layout, a horizontal layout, or a vertical layout, and they all work fairly similarly to each other. Since my buttons are in a vertical list, I'm going to go with the vertical layout group. And then I'm going to resize my empty game object to fill roughly the area that will cover these buttons. So let's give that a width of around, say, 1200, a height of around 450, an X position of 0, and a Y position of negative 180. And before we go through all of the options with the vertical layout group, let's just add another couple of buttons to our canvas. So we'll click on our button, and then if you just hit Control D to duplicate, that'll create a few more, and we want around 4 in total. And we'll see that they're automatically being put in a vertical list. And if you picked one of the other options, say the horizontal layout group would be organizing them horizontally, and the grid layout would be organizing them into a set grid. So let's look at some of these other options. We have padding for left, right, top, and bottom, and these are just the margins around the box. So if we increase the left padding, we'll get this nice margin down the left-hand side. So you can kind of think of these as margins in a word processing document. For now, I'm just going to leave the padding at 0. The spacing does a very similar thing, but it adds padding between the elements. So if we increase the spacing or decrease the spacing, you'll notice that the buttons get closer or further away from each other. And we have the child alignment options, which work again very similar to word processing. So we could say set this to middle center to center all of our buttons in the middle of the layout group. Now these other options underneath the padding and spacing options essentially allow us to control the size of our buttons, which is why we didn't worry about sizing our buttons before adding them to the layout group. What we're going to do in this case is tell our layout group to control the child size. So we can set the width, and notice that all the buttons are automatically stretched out to fill the layout group area. And we can also do the same for the height. And now we have the buttons filling the area we want. Now is going to be the best time to just adjust our padding and our spacing. And that is going to bring us on to your challenge. I want you to set up your buttons in the layout group. So if you haven't done so already, find an image and add it to your buttons. And rather than doing all of the buttons that you've added individually, it may be worth just focusing on the one and then copy pasting that or making a prefab so that you can reuse it for the others. And do remember to slice your sprites to keep them from stretching and warping when you resize them. Then once you've got one of your buttons set up, duplicate it and organize all of your buttons using a layout group. And finally, just play around with the spacing, the padding, and the alignment of your buttons to get them into the position that you want them. So pause the video now and give that a go. Okay, welcome back. So hopefully you've gotten well with that challenge and your buttons are all now nicely laid out on your canvas. Now before the challenge, I'd already sorted out the images for my buttons, but I haven't really fixed the padding and spacing yet. So let's add a little bit of spacing, and I'm just going to take this down to maybe around -10 to bring them a little bit closer together. And rather than adjusting the padding, I'm actually just going to change the overall height of my layout box. So I'm going to bring this down to maybe 430. And then if we have a quick zoom out so we can see the full picture and hide our pre-visualization canvas, I think that layout's not looking too bad. However, one thing I do want to fix is the button text because it's both very small and very faint. So just on the first button in the list, I'm going to click on my TextMeshPro element and head down to the options here. I'm going to increase the font size to maybe around 50 points. And I'm going to change the vertex color to full black. And now I think that doesn't look too bad. So to copy this along to the others, I'm just going to get rid of the others and notice the button has suddenly become an absolute giant. I'm then going to go ahead and prefab this button by just clicking and dragging it into the project window so that if I make any other changes to the buttons in future, I don't have to keep copying and pasting or changing one at a time. And then I'm just going to duplicate this button again another 3 times. Hi everyone, this is Gary from the future, just popping in to say that I've prefabbed a button here, but we haven't actually covered prefabs in the course yet. We're going to cover this in a lot more detail in the next section, so don't worry about prefabbing the button for this particular project because it really doesn't matter too much. Feel free to just copy and paste your existing button into the hierarchy and do any manual changes that are needed. So there we have our quiz really starting to take shape now. We've got space for the question, we've got space for the answer buttons. And in the next lecture, we're going to start looking at how to create the questions that are going to populate these fields. So I'll see you there. In this lecture, we're going to start creating the questions for our quiz using scriptable objects. Before we go ahead and start doing that though, there's a little bit of tidy up that we need to do in our project because our hierarchy is starting to get a little bit messy and so is our asset folder. So in our asset folder, let's clean this up first. And the first thing I want to do is just store away our font assets in the TextMeshPro folder. So let's open that up and we're going to drag the font TTF file into the fonts folder. And we're going to drag the font asset into resources, fonts and materials. We've also got this button prefab, but this button doesn't really tell us what it does. So let's give that a more descriptive name by just pressing F2, and we'll call this the answer button instead. And we'll also create a new folder for that. So right click, create folder, and we'll call this prefabs and drag that over into there. That tidies up our asset folder. So over in our hierarchy, let's do some work in here. And I'm not going to worry too much about the pre-visualization canvas or the background canvas, but the children of our quiz canvas could certainly do with some better naming. So I'm going to rename my text object to the question text. And under our answer button group, I'm just going to rename our buttons to answer button. And I'm also going to give it an index that starts at 0. And since these are all prefabs, I can just go ahead and delete these and then duplicate again. So we have answer button 0 through to answer button 3. With all that set up, finally, let's just add a couple of new blank folders to our assets, ready for the stuff that we're about to do. So the first thing I'm going to do is create a new folder called scripts, which will hold all of our C# scripts. And I'm also going to create a folder called questions, which will hold all of our scriptable objects. Okay, so project all set up. Let's actually talk about what scriptable objects are and how they're going to help us with our game. So what is a scriptable object? Well, it's really just a data container, so a way of storing data for our game. And they're useful because they keep this data out of our scripts. And this helps us to save memory by storing all of that data in a single place that our scripts can reference. They also don't need to be attached to game objects like normal mono-behavior scripts. And this makes them very lightweight and convenient to use. And probably the best way to think of scriptable objects is as a kind of template, so we can use them as a kind of blueprint, and this helps with data consistency. Some examples of where scriptable objects can be useful is for things like storing weapon statistics in an RPG, so things like the damage and critical chance and things like that. We could also use them to store card data in a collectible card game. And for our game, we're going to be using them to store question data. So things like the question text itself, all of the possible answers to that question, and also a reference to the correct answer. Now I mentioned that the scriptable objects kind of sit separate to the mono-behavior scripts that you're familiar with. So on the one side, we have our code, which might be a mono-behavior called quiz.cs. And in this script, we might have various methods for displaying the question on screen and checking the answer. And we could store all of the question data in this script as well. However, if we rip this data out of our script and store them in scriptable objects, we could then reference one of those scriptable objects when we need to get the question data that we're after. And this will then just look at the data in the scriptable object without actually copying it anywhere. Now, jumping back over into Unity, let's actually create some scriptable objects. In our scripts folder, let's right click and go up to create new C# script. And we're going to call this the question SO for scriptable object. Let's go ahead and open this up. And the first thing I want to do in here is to actually delete the start and update method, because not only are we not going to need it, we're not actually going to be able to use them with scriptable objects Because if we look at the class declaration at the top here, we can see that it inherits from mono behavior. And this will be the case for every script that you've written so far in this course. However, for scriptable objects, we actually want to change this from mono behavior to scriptable object. The next thing I want to do to make this scriptable object usable is to head above this class declaration and add an attribute. So let's open up some brackets, and we're going to use the create asset menu attribute. Now, to explain what this does, let's jump back over into Unity, and unfortunately we will be jumping back and forth between Unity and script quite a bit in this lecture. But if we wait for this script to compile, and then anywhere in the project window, let's go ahead and right click, and if we go up to create, we can see we now have a question SO at the top of this list. So that's what that create asset menu is doing for us. It's adding an option to create something in this list. And if we go ahead and click on this, we'll also notice it brings in a new scriptable object called new question SO. But question SO isn't the most descriptive of names. So to make this whole thing more usable, let's go ahead and just delete that test scriptable object I've just made, head back over into our script, and within this create asset menu, within the parentheses, let's go ahead and add a menu name. And I'm going to change this to just be a quiz question. And then to change the name of the file that gets created, let's go ahead and use file name and call this a new question. If we go ahead and save that now and jump back into Unity once again. Now, if we right click and go up to our create menu, we now have a quiz question. If we go ahead and click on our quiz question, we get a scriptable object called new question. Now, because our script doesn't really contain anything, our scriptable object currently does absolutely nothing. So let's fix that next and start adding some question text to our scriptable object. Back in our script, within the class itself, let's go ahead and add a new variable. And this variable is going to be a string, and we'll call this the question. Then to initialize this question string with some default text, I'm just going to say enter new question text here and cap that off with our semicolon. Next, we need to think about the access level for this variable. Now, we are going to need to be able to set this in the inspector. So your first thought might be to make it public, but we don't want this to be changed outside of our scriptable object, because if another class comes along and tries to edit our question, it's not going to be working on a copy of our question. It's actually going to be working on the question itself. So the text contained within our scriptable object will be changed on disk. So instead, let's make this a serialized field. This will give us the ability to set our question in the inspector, but not access this variable from another class. And we will actually need to be able to at least get the value of this variable from another class, but we'll worry about that in probably the next lecture. So with our serialized field in place, let's jump back to Unity to see the fruits of our labor. We can now see that we've got a new question string on our scriptable object with our default text already added. Now this is all perfectly fine and usable, but we'll find that as our text gets longer, so if I just add some additional characters here, we'll notice that it just sort of overflows off the edge. And so if your question is a little bit longer than just a handful of characters, it's going to be far more difficult to edit this later on and check it for typos and things like that. So to go ahead and fix this, let's once again jump back over into our script. And what we're going to do is add another attribute to our variable. So just above this, we're going to open some more brackets. And I'm going to use the attribute text area. Now what the text area attribute allows us to do is adjust and control the size of that text box in the inspector. This requires two parameters. It requires a minimum and a maximum number of lines that we want to display. So for our question, I think 2 would be a nice minimum size. And maybe let's go up to 6 as the maximum size, because if our question gets any longer than that, it certainly isn't going to fit on the canvas itself. So for the last time, let's save our script and jump back into Unity. And now we can see that our question box has now got bigger. And if we add some more lines, we can see we get a maximum of 6 lines visible to us at any one time. And if we shorten this down, we get a minimum of 2. And I think that nicely brings us on to your challenge. If you haven't done so already, then decide on the topic for your quiz, and then think of around 5 questions that you want to ask your players. Once you've got some questions down on paper, then go ahead and create the scriptable object that will hold these questions. And our scriptable object will only hold the questions at the moment, so for now, don't worry too much about the answers just yet, because we'll get onto those in the next lecture. So pause the video now and give that a go. Okay, welcome back. So hopefully you've now made a final decision on the topic for your quiz, and you've created some scriptable objects to hold your questions. Here I've already created 4 while you've been away in the questions folder in my assets folder. And for the final one, all we need to do is right click, go up to create, and then quiz question. Give it a new name, so let's call this question 5. And then finally let's add some question text. So my game is all about helping people learn C# and Unity. So I'm going to ask the question, what is a variable? However, since we don't have space to add our answers yet, we're going to leave things there. And in the next lecture, we're going to look at adding this functionality. So I'll see you there. In the last lecture, we set up our scriptable object and we created this string question variable to hold our question text. And in the process, we gave it a serialized field attribute, which allowed us to change it in the inspector. But when we come to write our quiz script later on, we're going to need to gain access to this variable or the data contained within this variable. So how do we go about doing that? Well, for this, we use a certain type of method that is commonly called a getter method, because it allows us to get the data within a private variable and return it to a different script. So let's gain a bit of a deeper understanding of what a getter method is and why we would use it. Well, a getter method will give a script from outside of our class read-only access to a private variable. So for our scriptable object, we mentioned that we didn't want other classes manipulating the data in our variable, and this will help protect the contents of that private variable on our disk. So pretty straightforward from a description point of view, but let's have a look at how we would write it. So let's create a new method in our scriptable object, and we're going to call this getQuestion. However, up until this point in the course, we've only used a very specific type of method where we would maybe have something like public void, getQuestion. But this doesn't allow us to get the question and return it to another script, because as we can see from our declaration here, it is public, so it will be visible from other scripts, but it's got a return type of void, and this means it doesn't return anything. For our question though, we want it to return a string back to another script. So what we can do here is, instead of having void, we can have a public string getQuestion, and this will now expect the method to return a string. As we can see at the moment, we're getting a red squiggly on our method name because it says that not all code paths return a value. So unlike a void method where we don't ever return anything, we just perform some logic in here. In this case, we need to return something back from the method, and we can do that using the return keyword. And what do we want to return? Well, we want to return the question. So this will now give us that read-only access that we're looking for. We have our private string question variable. We've given it some amount of write access with our serialized field so we can edit it in the inspector. But when it comes to other classes accessing this variable, they're going to have to go through this getQuestion method, and this will then return a copy of that question data. Now, hopefully that's all making sense, but to really illustrate the point, what I'm going to do is I'm going to make a second class in this script, and you don't have to follow along with this. This is purely to show you how this might work later on in the course. If I make a public class, and we'll call this test, and we can have multiple classes within the same script, which can be really handy for testing. If I was to get a reference to this question scriptable object, and just call it my question SO, If I then made a fairly standard generic void method, so we're just going to call this test as well because it really doesn't matter for the moment. If I was to access this question SO and use the dot operator to see what variables and methods I have access to, if I try and type question, I won't have access to my question variable up the top here, but you may have noticed there that I do have the getQuestion method. And if I cap it off with the parentheses, everything is fine. And we can see if we hover over, it's returning us a string. So if I also create a variable here of type string, called the question text maybe, I can set this string variable to the result of getting the question out of the scriptable object. So hopefully that makes a bit of sense. Don't worry too much about this red squiggly here. This is just because I've named the method the same as the class. So if I call this test A, this would go away. But hopefully this getter method that we've created up here is now making a bit more sense. We've really just controlled the flow of access to the data within our scriptable object, which is really good for protecting it from accidental changes. So that's all for this one. Quite a short video, but hopefully this getter method is all making a little bit of sense. And in the next lecture, we're going to finish off our scriptable object by adding a couple more variables at the top for storing our answers, and also creating some other getter methods to return those answers to our future scripts. So to sign off, I'm going to get rid of this test class that we don't need, and I'll see you in the next lecture. In this lecture, we're going to finish off our scriptable objects so that they also hold the answers to our questions. And in the process, we're going to learn a little bit more about arrays. So here we are in one of our scriptable objects, which is currently only holding the question text. So let's have a think about how we're going to store the answers to our quiz. Well, on our canvas, we have 4 buttons, so one for each answer. So your first instinct might be to store each answer as its own unique string. This is a perfectly fine approach, but it is a little bit cumbersome and not very flexible. So rather than doing it this way, what we're instead going to do is use something called an array. So what is an array? Well, you can think of them as a grouping of multiple variables of the same type. So if we think about this in terms of our answers, rather than having 4 unique string variables, we could have a single array of strings. Now, when we group variables into an array, each item that we store in that array is called an element, and each element can be accessed within the array by its index number. So they're very easy to work with, especially when we start looking at looping through them. Now, one thing to note about arrays, and a lot of things in computers in fact, is that counting starts at 0. So the first element in an array is element 0. And this is initially quite confusing if you're not used to this 0 indexing that computers use. But with a little bit of time and a little bit of practice, this will soon become second nature to you. So let's look at an example of what an array might look like. Well, here we have an array of odd-numbered integers, and specifically we've got the first 5 odd numbers. Now, just like any other variable, we have declared the type at the front, so this is storing integer values, but notice these brackets after the type declaration. These brackets indicate that we're now dealing with an array of integers rather than just a single integer. We have our name of our variable just like any other, so we've called this one the odd numbers, and we've initialized it with the first 5 odd numbers. So notice that we've used these braces on either side, and then we have 5 elements inside this. But because we start counting at 0, each element within that would have an index of 0, 1, 2, 3, and 4. And again, this can be a little bit confusing if you're not used to this 0 indexing, but please do trust me on this, that the more that you work with them, the easier this does become. Now, this isn't the only way to initialize an array, so we don't necessarily always know what values we want to place in the array. And when that happens, what we can do is we can initialize it like this. So the front is exactly the same. We've still got an array of integers called odd numbers, but now we're initializing it as a new array of integers with a size of 5. So we're saying that this array will have 5 slots, if you like, 5 elements contained within it. And then later on, we might access one of those elements by its index number, and then change that the same we might change a regular old integer. So let's jump over into our scriptable object now and see these arrays in action. Now the answers to our questions are generally going to be strings, and to make it into an array, I just need to open some brackets. I'm then going to give my variable a name, so let's call this the answers. And because I don't necessarily know what the answers are going to be ahead of time, all I know is that each question will have 4 answers. I'm going to initialize my array by saying that it's equal to a new string array, so with the brackets open there, and within these brackets, I'm going to put the number 4. So there's going to be 4 elements to my array. The next step, now we've set up the core of our variable, is to think about the access level that it needs. So just like our question, we're going to want to be able to change them in the inspector, but we don't want to be able to change them from outside the scriptable object. So for this, I think a serialized field is again a very good choice for the access. And if we save our scriptable object and jump back into Unity, we'll see that we now have this rolled up option for answers in our scriptable objects. So we can unroll this and we have 4 elements. And notice the elements start counting from 0 up to 3. And we can go ahead and then fill in the potential answers to our question. Now that this question has some answers attached to it, we now need to know which one is the correct one. So now we're going to need another variable attached to our scriptable object to tell us which element of this array holds the correct answer. So back over into our scriptable object, let's again create another new variable, and this time it's going to hold the index number for our answer. So before you just follow along with me, see if you can write this variable for yourself. And this isn't a full challenge, so I'll just give you a moment to think before carrying on. Okay, so this is going to be an integer type because we're asking for an index number for our array. And I'm going to name this the correct answer index. Now we need a way of setting this in the inspector, and we still don't want this to be public to other scripts in our game. So let's again use a serialized field. And that will now give us a way of storing the index to the correct answer. So if we stored, say, the number 3 as our correct answer index, this would relate to the 4th element of our answers array. Because again, remember that this starts counting at 0. Next, we want to go ahead and finish off our scriptable object. So just like with our public getter method for our question, we're going to need a getter method for the correct answer index and another getter method to get an answer at a specific index. And I think that brings us nicely on to your challenge. I want you to create 2 more getter methods. The first one is going to be called getCorrectAnswerIndex. So think about the access level of the method, the return type of the method, and what variable it's actually going to return. And the second one, which is a little bit more complicated, but not by much, is going to be called getAnswer. And I say this one is a little bit more complex because this one is also going to accept a parameter of type int, which is going to be called index. So that when you use this method from outside the script, you can pass in the index for the answer that you want and get that particular answer out of our answers array. So pause the video now and give that one a go. Okay, welcome back. So hopefully you got on well with both of those, but don't worry too much if you struggled with the second one. Let's go through both of them now. For the first one, to return the correct answer index, our getter methods are always going to be public, and in this case, it's going to return an integer. And we said that we were going to call this one getCorrectAnswerIndex. And all this one is going to do is return the correct answer index. So congratulations if you managed to do that first one without any problems. And now let's look at the second one. And I'm actually going to put this one just above. It doesn't really matter where you place it. So if you put it below, then that's absolutely fine as well. And again, it's a getter method, so it's going to have to be public so other scripts can use it. and it's going to return a string. And this is just a single string, so not an array of strings. And we said this was going to be called getAnswer. We also said that this was going to accept a parameter of type int called index. And for this one, we want to return the answers at the index that we've specified. So what this method is doing is it's passing in an index that we want to use, and then just returning the answer at that given index. And if we go ahead and save our script and head back over into Unity, we now have our complete scriptable object. We have space for the question, we have space for our 4 answers, and we can also specify the index for the correct answer. So in this case, the correct index is 0, but we can place any number in there that we like. So it might be that we need the correct answer index to be 2. Now, one thing to be very careful of going forward is that this correct answer index is currently unconstrained, so we can have the correct answer of -56 or the correct answer of 54, and we should probably try and prevent that so the designer doesn't accidentally put in something crazy. But for now, we'll leave it as it is, and we may come to fix that in a later lecture. For now though, I think we've spent long enough on our scriptable object, and it's about time we started actually displaying our questions on the canvas that we worked so hard on. So that'll be the subject of the next lecture, where we finally start displaying all of this information on the canvas. So I'll see you there. Now that we have our scriptable objects storing our question data, it's time to connect them to the UI. So the first thing we want to do before we can connect these up is to create a new script. And we're going to create this script on the quiz canvas. So let's scroll down in the inspector and add a new component. And we'll call this new script quiz. So this script is going to handle the majority of our game logic. And to keep our assets folder tidy, let's move our quiz script into the scripts folder. Now let's go ahead and open up this quiz.cs script. And the first thing I like to do in any new script is to just delete these comments above start and update, because once we've been using Unity for a while, we don't really need them and they're just taking up space and causing clutter. And whilst we may need it later, we're not actually going to need the update method for now. So let's clear that out as well, just to keep our script as tidy as possible. Now with all that set up, let's think about how we're going to get the question text out of our scriptable object and onto the canvas. Well, the first thing we're going to want is a variable to hold the scriptable object that we're working with. So let's create that variable, and this variable will be of type question SO. So just like we can have variables for things like strings and integers, we can also have variables that relate to the name of another script. And we'll go ahead and call this question for now. And for the access level, personally, I really do prefer to keep all of my variables private unless I need extra access. In this case, we're not currently accessing this from anywhere else in our code, but we will need to still be able to set this scriptable object in the inspector. So rather than leaving it as a private variable, let's upgrade it to a serialized field for now. And if it turns out that we need this information in another script later on, we can always come back and make it public. The next thing we're going to need access to is the text element on our canvas. And to do this, we're going to have to add something to the very top of our script where we have all of these using statements. And all these using statements really do is just controls what code our script currently has access to. Now we're going to need access to the TextMeshPro element on our UI canvas. So let's add the using statement tmpro. And the capitalization is important here. So we have capital TMP and then the lowercase ro at the end there. And this will open some additional options for us. So let's create another new variable to store a reference to this TextMeshPro object on our canvas. And this is going to be of type TextMeshProUGUI. So as we start typing, we'll see the IntelliSense gives us two options. We have a TextMeshPro, which is predominantly for text that's actually existing in our game world, and TextMeshProUGUI, which is for any UI-based text. So the one we want here is our UI-based text. So let's pick TextMeshProUGUI. Then we need to give our variable a name. So let's call this the question text. And again, for the access level, we are going to need to set this in the inspector. So let's just go ahead and make it a serialized field. And again, if we need to change the access later on to make it more public, then we can come back and do that. So there are two main variables. We're going to have a reference to the question and a reference to the text element on our canvas. And now we need to connect the two. So let's very quickly pop back over into our scriptable object because we did create some getter methods in here. So what we're trying to do is we're trying to return this question string, and we can do that with this getQuestion method. So jump back over into our quiz script, and we're going to say that the question text dot text. This is going to set the text field of our TextMeshPro object on the canvas. And we're going to set that equal to be the question dot get question. So let's save up our script and see what this does. Let's jump back over into Unity and wait for things to compile. And now if we go ahead and click on our quiz canvas and scroll down to see our quiz script that we've just written, we need to fill in the question text from our UI. So let's just drag that over from the hierarchy into question text. And we need a question to add to our canvas. Now we're currently only worrying about one single question rather than the whole array of questions that we have at the moment. So let's go over to our questions folder and pick any one of our scriptable objects for now and drop that into the question field. And now if we go ahead and hit play, we should see this lorem ipsum text change to the text from our question. And here we go, we've now got the question displaying correctly when we're in play mode. So that puts us one step closer to our final game, and that's going to be all for this lecture, quite a short and sweet one. But in the next lecture, we're going to follow a similar kind of process and connect all of the answers to our buttons. So I'll see you there. In this lecture, we're going to carry on connecting up our UI, and this time we're going to connect the answer text to the answer buttons. So let's jump straight into our quiz script. And the first thing I want to do in here is to create a new variable to store our buttons. Now for our variable type, we could go ahead and store the button component directly, but because we're not really going to be doing much with that button component, and instead doing things like changing the text components and the image components, what we'll actually do is create this variable to be of type GameObject. And since we have 4 buttons for our 4 answers, let's make this an array. So remember to add those brackets at the end of the type declaration. Next, our variable is going to need a name. So I'm going to call these the answer buttons. And for the access level, I'm again just going to go with a serialized field. Now, if we go ahead and save our script and head back over into Unity, if we select our quiz canvas and scroll down in the inspector, we now have an array for our answer buttons, and this list is currently empty. Now, we could go ahead and just drag in each one of our game objects into here to populate them one at a time, but a quicker option is to actually go up to this padlock in the top right corner, and then if we select all of the objects that we're interested in, the inspector won't change, and we can go ahead and drag all 3 of the remaining ones, or all 4 if you didn't do the first one, and drop them into this array. Now that's all populated with all of our answer buttons. We can go ahead and unlock the inspector, so click on the padlock item once again. Now let's go ahead and think about how we're going to change the text on these buttons. If we take a look at the composition of one of our buttons, the text component that we actually want to change is a child of our button game object. So in our script, rather than trying to get a component from the root object, we're going to look at getting a component in the children. So let's jump back over to our script. Down in the start method, let's go ahead and look at how to get that text component from the child object. Well, for this, I'm going to set up a temporary variable of type TextMeshProUGUI, and I'm going to call this button text. And for the moment, we're just going to worry about the first answer for our question. So I'm going to take the answer buttons and I'm going to look at the very first element, so element 0. And because this is a game object, I can go dot get component in children. And the type of component I want to find in the children is going to be this TextMeshProUGUI. And this will now look through all of the children of our answer button and find the first TextMeshPro component that it can. And now we have that reference, we're going to change the text on that button to the first answer from our stored question. And this is going to be your challenge. I want you to change the text being displayed on our button to the first answer that's stored in our scriptable object. So this is going to be a similar process to how we got the question text from our scriptable object, but remember that getting the answer also requires us to pass in the index of the answer that we want. So pause the video and give that a go. Okay, welcome back. So hopefully you got on well with that. And to cover off how we do this, we're going to say that the button text.text is going to be equal to our question.getAnswer. And because we're currently only interested in the very first answer, we can just pass in the index of 0. Now, if we go ahead and save our script and head back over into Unity, and now if we go ahead and hit play, we should find that the question is being pulled in, as is the first answer. So we're a quarter of the way there, and now we just have to worry about the other 3 buttons. So let's come out of play and jump back to our script. And just like we've done this first one, we could just copy and paste these 2 lines another 3 times, and then just change the index. So we have index 0 up to index 3. However, this is going to make our code look absolutely terrible. It's going to be difficult to manage and a nightmare to debug. So instead, what we're going to do is use a loop. And specifically, we're going to use a for loop. So what is a loop? Well, a loop in code really just repeats an event until some condition gets met. And they're very powerful for counting or iterating. And one type of loop, and the loop that we're interested in, is called a for loop. And a for loop allows us to loop through our code a set number of times. So let's look at what one of these for loops actually looks like. So here we have the basic format for a for loop. And if we take a closer look inside the parentheses of the for loop, we'll notice that it's kind of broken into 3 sections, each delimited by a semicolon. So this first piece of the for loop is known as the initializer, and this part of the for loop runs at least once before the code block underneath is executed. And we use this initializer to set up something called the iterator. And you can think of the iterator really as just a type of counter. So we're creating a temporary variable called I, and we're setting this to 0. So I in this case is our iterator. Next up, we have our second statement, and this is the condition. So while this statement is true, our for loop will run. So in this case, our for loop will run while our iterator I is less than some number n. Now, when you're writing these conditions, it's important to be mindful and be careful of infinite loops, because an infinite loop will crash your program and generally lead to you having a bad time. Finally, we have the iterator phase of our for loop, and this part executes at the end of each loop. And as I'm sure you may be able to guess from the syntax, we use this to either increment or decrement our iterator. So in this case, we've got I++, so on every loop, I is going to be getting increased by 1. So with the basic syntax and structure out of the way, let's actually create one of these for loops to loop through our buttons. Back over in our quiz script, let's create some space because these 2 lines are actually going to go inside of our for loop. So let's create the for loop by saying for, and then opening some parentheses. We then need to initialize our iterator. So we're going to say int I equals 0. And we can really set this to any variable name and any number that we like. But since we're going to be looping through an array which starts counting at 0, then this seems like a sensible option. We can then place a semicolon to end that part of the statement. And next we need to think about when we want this loop to run. Well, we want this loop to run while I is less than the length of our answer button array. And we can get the length by saying answerbuttons.length. Finally, we need to set up the iterator condition. So every loop we want to increase I by 1. So let's put I++. Then we'll create the code block and just copy and paste these 2 lines of code into there. Let's do some quick tidy up, and we now have our loop. Finally, there's one more thing we need to change, and that is that we're currently only looking at the first answer. So if this was to run at the moment, we would loop through this 4 times, but every time we do that, we're just going to be setting the same answer button with the same answer. So let's change this 0 to our I, and again in our get answers. And now every time I gets increased by 1 on each loop, we're going to be getting the next button in our list and getting the next answer from our question. So let's go ahead and save this script and see this in action in Unity. And if we go ahead and hit play, we now have our question being asked and all 4 buttons receiving an answer. So hopefully you can see the power that for loops give us in both cleaning up our code and automating the repetitive tasks that we would otherwise have to write in our code. Now our quiz is certainly coming along, but we still can't click on any of our buttons to check our answers, and we also only have 1 question in our quiz. So in the next lecture we're going to start remedying that and checking the answers that the player has clicked on. So I'll see you there. Now that we're successfully displaying the question on screen, it's time to start thinking about how we're going to accept the player's answers. So let's start by just explaining the kind of logic that we want to go through. So on our quiz canvas, we have our question text at the moment, but when it comes to the player clicking on a button, we're going to want to change this text field to the answer. Now we've already played around with editing this text in code, so that part shouldn't be too difficult. The more challenging part is going to be dealing with the actual buttons, because we haven't really done anything with these just yet. If we click on one of our buttons in the hierarchy and scroll down, what we're going to eventually want to do is have our sprite change. So we're going to do this programmatically, and we're also going to need to run some code when a button is clicked on. And if we look in the button component, this is where this on-click event system comes in. So let's jump over into our quiz script. And the first thing I want to do in here is to add some extra variables. The first one is going to be a reference to the correct answer index for our question. So this is going to be of type int, and I'm just going to call this the correct answer index. Next, I'm going to want reference to our 2 button sprites so we can switch those in and out as we need. So this will be of type sprite, and we'll call the first one the default answer sprite. And we'll call the second one the correct answer sprite. To make them visible to the inspector, let's make them a serialized field. So now let's have a look at the method that we're going to connect to this button press. So if we scroll down and add a new method under start, this is going to be a public method, so it can be called from anywhere. It doesn't need to return anything at all, so we can just return a void on this one. And I'm going to call this method onAnswerSelected. Now we're going to be connecting this method to all 4 of our buttons, and we're going to need to know which button it was that called it. So we're also going to pass in a parameter, and we'll just call this index. So if it's the first button in the list, we'll pass in a 0 and so on. And doing this means we can then double check this against the correct answer index from our question. So with that in mind, let's create the if statement first of all. So we can say that if the index equals the question.getCorrectAnswerIndex, and remember that was one of the getter methods that we wrote from our scriptable object, and if the answer is correct, then we're going to want to do a few things. We're going to want to change the question text itself, so we can say questionText.text. And for now, I'm just going to have a default message of correct. and we might embellish or improve on that later on. Next, we're going to want to change the button image for this particular index to the correct answer sprite. So the first thing we're going to want to do is grab a reference to our button image. So let's create a temporary variable for that. And this will be of type image. And we'll call it the button image. And notice we're currently getting some red squiggly lines because the namespace of type image can't be found. So if you're in Visual Studio Code like me, you can hold Control and then the period key. And what we need is using Unity Engine UI. So if we click on that, that will then solve our red squiggly there. And if we scroll to the very top where our using statements are, we can see that we've now included using Unity Engine.ui. So with our using statement all set up, let's scroll back to where we are in onAnswerSelected. And now let's find this button image that we're after. Well, this is going to be the image component of our button game object. So we can say this is going to be answer buttons at the index that we're interested in, dot get component of type image. So that's going to grab the image component off of this current answer button. Then with access to that image component, we can say that the button image dot sprite is going to equal the correct answer sprite. So that's pretty much our if statement for when we get a correct answer. And we are going to also have to write another statement for when we get an incorrect answer. But let's just save our script for a moment and jump into Unity to see this in action. On our answer buttons, I'm just going to control click to select all of them together. And then in the button component under on click, we're going to add the little plus button to add a new item to our list. We're then going to drag over our quiz canvas because that's where our quiz script is located. And then in the drop-down box, we're going to go from no function. We're going to go down to the quiz script and scroll down. We'll find on answer selected. So let's click on that to connect them up. And in this field underneath, this is where we're going to pass in the index number to that method. So for our first button, that's going to be index 0. On answer button 1, if we select that, we can change that to a 1. And then on answer button 2, we can change it to a 2. And finally, answer button 3, we can change it to a 3. Next, before we go and hit play, let's jump over to our quiz canvas. And then let's populate these two fields with our sprites. So we've got a default sprite. I'm using this blue neon square. And my correct answer, I'm going to use the orange version. And with all that set up, let's go ahead and hit play to see this in action. We have our question all set up here, and feel free to give it a quick read and shout at the screen if you do know the answer. And in this case, the answer is the first option. We can now see that our message is changing and our button has also changed to the correct option. However, if we restart our game and select an incorrect option, nothing at all happened. So back over into our script and down in onAnswerSelected, what we're going to do is we're going to need to create an else statement. So if we're not right, we're going to be wrong. And for this block of code, we're going to have to do something very similar to what we've just done for when we get a correct answer. And rather than setting the button sprite for the button we've clicked on, we want to set the sprite for the correct answer out of the list. And I think this would be a fantastic challenge. So for your challenge, I want you to change the question text to display the correct answer. And I want you to change the image on the button that contains the correct answer. So quite a big challenge, but the syntax isn't too much different to what we've already written. So pause the video now and give that a go. Okay, welcome back. So quite a big meaty challenge there, but hopefully you got on okay with it. And let's start by looking at the first part of the challenge, which was to change the question text. Well, to set the text will be very similar to before, but first we're going to need to get the text for the correct answer. And to do that, we're first going to need to find the correct answer index. So let's do that first and write the correct answer index equals the question.getCorrectAnswerIndex. So we're just going to grab that from our scriptable object. We can then store a temporary string variable called correct answer. And this is also going to come from our scriptable object. So we can say question.getAnswer, and the answer we want is at the correct answer index. Finally, we can use this to set the text on the canvas. So we can say question text.text equals the correct answer. So if you managed to get that far, then very well done. However, I'm actually going to improve this just a little bit. Rather than just having the correct answer displayed on the canvas with no context, I'm going to add a short little message at the front and say, sorry, the correct answer was, and then the correct answer. Now, to improve the formatting slightly, rather than having this all on one continuous line that overflows, I'm actually going to break this into 2 lines. So at the end of my string, I'm going to add the new line character, which we can do by writing \n. This will then break our string apart and place the correct answer onto a second line. Now onto the next part of the challenge, which was to change the button image. This is going to be very similar to what we did before. And again, we're going to need a temporary image variable. So rather than creating our temporary variable here, what we're going to do is we're just going to promote this out of our if block and up into the method itself. And then we can fix up that line to get rid of our red squiggly. Now this step isn't strictly necessary, so if you have created a second temporary image variable, then that's absolutely fine. Doing it this way though does give us a slight performance advantage and uses less system memory. So whenever you have a variable that may be used multiple times, it's a good idea to promote them in this way for a small performance improvement. And now we can reuse this variable within our else block. So we can say that the button image is going to be equal to our answer buttons, and rather than being at the index, we're going to want the button at the correct answer index. And then we can finish that line off by getting the component of type image off of that button. And then to set the sprite, it's exactly the same as we did in our if block. So I'm just going to copy and paste that into there. So with that all set up, let's save our script and jump back into Unity. And now if we go ahead and hit play, if we click on an incorrect answer this time, we get a new message to say that the answer was incorrect and to tell us what the correct answer was. And we also get the highlighted answer in the list. So our quiz game is coming along nicely. However, we do have a little bit of a bug, because even though we've answered this question, our buttons can still be clicked on. So if we decide to then go ahead and click on the correct answer, we can magically change our wrong answer into a right answer. And that's not necessarily what we want to happen. So in the next lecture, we're going to look at how to disable our buttons once we've selected an answer, and then re-enable them when a new question is presented. So I'll see you there. Our game is now at the stage where the player can click on one of the answer buttons and be told whether they got the answer right or wrong. But we do have a little bit of a bug here, because even though we've now selected an answer, there's nothing to stop us from selecting a new answer and potentially changing our result. And the thing that's controlling this is on the answer buttons. So if we go ahead and click on one of our answer buttons and scroll down to look at the button component, we have this interactable toggle flag. When it's checked, that means the button can still be clicked on. And if we disable it, then the button will no longer work. So we want to look at doing this programmatically and disabling the buttons when an answer has been selected. So let's jump over into our quiz script. And before we go ahead and do this, I do want to do a little bit of refactoring and tidy up our start method. This was some of the first code we wrote, and whilst it's fine to stay in the start method for now, it really is a good idea to tidy that up and put it in its own method so that we can reuse it later, and also just to wrap it up with a nice name so that we can remember exactly what it does. So let's scroll down and make some space for it, and keep all of our code tidy. If we hover over by the line numbers, we can actually collapse down sections of our code to hide it away. So underneath our public method, we're going to create a new private method, and this doesn't have to return anything, so we can make it a void, and we're going to call this method display question. because if you remember, this code in Start at the moment pretty much just displays the questions and answers on the canvas. So let's then go ahead and cut and paste all of our code into that new method. And then we're going to go and call this method from within Start. So not a drastic change to our code or performance there, but whenever we do things like this, it is a good idea to just save the script and pop back into Unity to double check that we haven't broken anything. So if you want to err on the side of caution, then go ahead and do that now. I'm not going to worry too much. I'm fairly confident that I've got it right. And now we can start thinking about our buttons. So let's have a quick look at the game flow that we're after. First of all, we're going to display a new question to the player. And in doing so, we're going to turn on all of the answer buttons. Then, once the question has been answered, we want to turn all the buttons off and then loop back round to potentially display a new question. So for turning the buttons on and off, we could have two separate methods for this, one to set them all to true and one to set them all to false. But because the logic for both is incredibly similar, we're going to look at killing two birds with one stone and just writing a single method. So back into our quiz script, and at the bottom underneath display questions, I'm going to create another new method that will set the button state to whatever we pass in. This method doesn't need to return anything, so we can make that void, and we'll call it setButtonState. Then to tell it what state we want, we're going to pass in a bool and call this the state. So that's just going to be true or false. This method is then going to have to loop through all of the answer buttons. So very similar to what we're doing when we're displaying a question up here. So let's say that for int I equals 0, our condition will then be when I is less than the answer buttons dot length, and our iterator will be going up by I++. Next, we need to find a reference to the button component on our answer button game object. So we can have a type button, and we'll call this the button. And we're going to set this equal to the answer buttons at index I dot get component of type button. With that reference to the button in hand, we can then go ahead and say button dot interactable. Not is interactable. That actually tells you the state that it's currently in. We want dot interactable. And that will allow you to set that flag. So do be careful. There are a few methods dotted around Unity that are like that you may think do one thing, but actually do something else. But with the correct one in hand now, the button.interactable, we're going to set this equal to the state that we're passing into our method. So that will either set that flag to either true or false. Next, we need to call this from somewhere. And we said we wanted to set this button state when we get a new question and put it on the canvas, and also when the answer has been selected. Well, let's do the answer selected version first. So let's scroll up to where our onAnswerSelected method is. It's currently rolled up, so we just need to go next to the number line here and unroll that down. And then down at the bottom of that method, once we've done all of our other work, let's go ahead and call that setButtonState method. And we're going to pass in false because we want to disable the buttons at this stage. So that takes care of disabling the buttons, but we are going to need to re-enable them at some point. So let's have a think about where we're going to do that. Now we could put it in display question because that's roughly when we're going to want to do it. However, later on, we are going to be doing some other stuff around getting a new question as well. So rather than making this method do more than one thing, let's create another method above it. And this again is going to be a void. And we're going to call this one getNextQuestion. Then inside this method, we're going to set the button state back to true so that the player can click on the buttons again when we get a new question. And we're also going to display the question. So with that set up, let's save our script and jump back into Unity. Now, if we select an answer and then try and click on a different answer, we'll notice that all of the buttons have been disabled. So that's the disabling of the buttons now working. And unfortunately, at the moment, we're not going to be able to see the re-enabling of the buttons because we do only have one question in our quiz. So for now, we're just going to have to kind of hope that that works. And if we have any problems, we can always come back to it later. So as a developer, it may just be worth making a note to say that that feature is currently untested. And talking of untested features, there is one more thing that I want to do in this script because it's going to set us up nicely for a later lecture. And it's also a very good excuse to have a challenge. Because in addition to resetting the button state when a new question is presented, we're also going to want to reset the button sprites so that we don't continue to highlight the old answers that we had from the previous question. So when we get our next question, which again, we're not currently calling at the moment, we're going to set our button state to true. We're then going to set the default button sprites, and that's a method that we're about to write. And then we can go ahead and display our new question. So let's go ahead and write this method. And we'll do that down at the bottom underneath set button state. We can say void set default button sprites. And writing this is going to be your challenge. I want you to write this set default button sprites method. Now, using the code that we've already written in this section, you should be able to piece together how to do this on your own. But if you would like to hang around for some extra logic, then the logic for this method is going to first be to loop through all of our answer buttons, which we've done many times now. We then want to get the image component off of each one of those buttons and change the sprite back to our default sprite. So pause the video now and give that one a go. Okay, welcome back. So hopefully you got on really well with that challenge because it is something we've done a few times now. So for this, we're going to need a for loop to loop through our buttons. So we can say for int I equals 0. Our condition will be while I is less than the answer buttons dot length. And we're going to iterate by 1 every loop. We then want to store a reference to an image component. So we can say image button image equals the answer buttons at index I dot get component of type image. And then we can set the button image dot sprite to be equal to the default answer sprite. So congratulations if you managed to complete that challenge and piece all of that together. And to just double check that this is all working, let's actually go up to start. And rather than calling display question here, let's call get next question. Because at the moment, this should be fine for testing. Let's then jump back into Unity and just go ahead and kind of break things just a little bit. So on our buttons, we're going to turn them off by default for testing. And I'm also going to change the sprites to the answer sprite by default. Now, what this will mean is that if our methods that we've written have worked, then when we press play, these buttons will change back to our blue default sprite and the buttons will be clickable. So let's go ahead and hit play and test this out. And indeed, everything has worked. And now that everything's working for a single question, I think it's time to start adding our other questions to our game and looking at how to switch between them. So that's all for now, and I'll see you in the next lecture. There are many ways that we could look at changing from one question to the next, but I think using a timer would be a good idea here. We can give them a set amount of time to answer the question before automatically showing them the answer. We can then display that answer for a fixed amount of time before automatically showing them the next question. So let's look at how we might implement this almost turn-based timer. So the first thing we need to do is to place the timer onto our canvas. So let's open up our pre-visualization canvas to see where we want to place it. And I've got mine in the top right corner here. And all this really is just a plain image where we're controlling the fill amount. So over on our quiz canvas, let's right click, go down to UI and then bring up an image. And we'll call this the timer image. Before we move it into place, let's drag over our image sprite. So I'm going to use this neon round orange sprite. And now if we zoom in a little bit so we can get the positioning correct, We can then drag that into place. And now it's just a case of resizing it. Now with our timer in position, we can go ahead and hide our pre-visualization canvas. And then do any final movement tweaks for our timer based on our current design. So I'm actually going to bring it down ever so slightly. And now to make it act like a timer that's going to empty over time, let's go down to the image component, and where we've got the image type, we've previously changed this to sliced for our buttons, but this time we're going to change this to filled. Now this has given us a whole bunch of extra options. So as it's set up at the moment with Radial 360 from the bottom, if we go ahead and decrease the fill amount, we'll notice that it starts to carve away at our image. Now I think the Radial 360 is going to be fine for us, but if you want a different one, then you can just select it from the drop down. For the fill origin, I'm actually going to change this to the top. And rather than going clockwise to fill it up, we're going to go anti-clockwise or counterclockwise, so that as we reduce the fill amount, it starts to go down a bit more like a clock. And now it's time to create a new script which is going to control how this timer works. So in our scripts folder, let's right click and create a new script. And we'll call this the timer. As for where we're going to place this timer in our game, we could reasonably put it wherever we think is most sensible. So we might put it on the quiz canvas itself, but I think I'm going to create a new empty object and just call it the timer. This is a fairly separate component from the actual quiz mechanic itself, so it makes sense to be on its own object. Now, before we go ahead and write any code, let's think about what our timer script needs to do. Well, first, it's going to need to know what state the game is in. So, is the player currently answering a question, or are they being shown the answer? Next, the timer is going to need to know if the time has run out for one of those given states. If it hasn't, then we're going to need to keep track of the fill amount for the timer image on the canvas. And when the time runs out, we're going to want to change the state of our game. So if we're currently in the answering question state, we're going to move over into the showing answer state, and vice versa. So let's jump over into our script. And as always, I'm going to delete the comments above the start and update. And I'm also going to get rid of the start method because we're not going to need it. One important thing for our timer though is to keep track of how long we've got left for our question. So let's do this with a float variable. So we'll have a float and I'll call this the timer value. And to set this timer value, we're going to have two other float variables, one for the amount of time we have to answer the question, and another one for how long we've got to review our answers. So let's make these serialized fields, and they're both going to be of type float. The first one I'm going to call time to complete question. And we'll maybe give the player 30 seconds for that one. And the second one, another serialized field of type float. And we'll call this one time to show correct answer. And let's maybe give this one 10 seconds. So for our game, we're going to have a 30-second window to answer the question. And once that time has elapsed, we'll have a 10-second review of the answer before we eventually flip back to the next question and give another 30 seconds on the clock. With those set up, now let's think about the methods that this timer script is going to need. Well, the main purpose is really going to be to update this timer value based on the state of the game. So let's get this updating first of all. Now we could do this all in update, but I'm actually going to create its own method just for readability. So let's say void update timer. And every frame of our game, we want to be reducing this timer value. And we can do that by saying timer value minus equals time dot delta time. So every frame of our game, we're going to shave off a little bit of time from our timer value. Now, if you've never seen this minus equals syntax before, this is really just a useful shorthand that we can use. And what it essentially does is takes the value on the left and takes that and subtracts the amount on the right. So another way that we could write this in a longer format would be timer value equals the timer value minus time.delta time. So here we're taking our initial timer value and we're then setting this equal to what it was before minus time.delta time. So that's what this minus equals syntax does. So to save us a bit of time, rather than having to write all of this out, we can just use this nice shorthand syntax to collapse our lines and make them shorter. And then once our timer reaches 0, we want to set it to either our time to complete question or our time to show correct answer. Now we'll build that in a second. For now, let's just get it counting down. So we can say that if the timer value is less than or equal to 0, then we want to reset the timer value. So for now, I'm just going to set our timer value equal to the time to complete question. And so that we can test this in Unity and see what it's doing, let's add a debug.log message at the bottom here, which is just going to print out our timer value. And finally, to call this method, let's go to our update method and call update timer. So if we save our script here and jump back into Unity, if we head over to our console so we can see our log messages, and we can just clear this warning for the moment, that's going to be cleared up later on. Next, let's click on our timer in our hierarchy, and let's just lower this time to complete question to something fairly short so we don't have to sit here forever testing it. So I'm going to set it to 5 and hit play. And now in the console, we'll see that it slowly ticks down from 5 down to 0. And then once it hits 0, it goes back to 5 and carries on counting down. So we've got a nice cyclical timer here just based on our one variable. So let's come out of play mode and set our variable back to around 30 seconds. Now we've done testing that timer functionality. And if we head back into our script, the next thing we want to think about is how we're going to switch between our time to complete next question and our time to show correct answer. For this, I'm going to need another variable, and I'm going to pop it above the timer value because I'm actually going to make this one public for now, because over in our quiz script, we're going to want to have access to this variable. And we could go through the process of creating getter methods and things like that. But for such a small game, I don't think it's going to be much of a problem. So we're going to have a public bool, and we're going to call this is answering question. And initially, we're going to set this to false. With that all set up, now I think is a good chance for a challenge. So your challenge for this lecture will be to change the state of our is answering question when our timer value reaches 0. So this will be down in our update timer method. Then, once you've changed the state, I also want you to think about setting the timer value to match the state that we're in. So if is answering question is true, when the timer runs out, we want to set that to false and change the timer value to the time to show correct answer. Otherwise, we essentially want to do the opposite. So see if you can get your timer flipping between these two states. Pause the video now and give that a go. Okay, welcome back. So let's head down to our update timer method. And in here, we first of all want to say that if is answering question is true, then if our timer value is less than or equal to 0, then we want our timer value to be equal to the time to show correct answer. And in here as well, we're also going to toggle the state of our is answering question Boolean. So we're going to say is answering question equals false. So if it is true and we've run out of time, we're going to say that the question is now false, and we're going to change over to our showing of the correct answer. Otherwise, if answering question is false, we can say else. And then we also again want to ask if the timer value is less than or equal to 0. Then is answering question is going to be set back to true. So again, we're just flipping the state of our timer, and we're going to switch our timer value equal to the time to complete question. We don't need this final if statement anymore, so let's get rid of that. And if we again save and jump back over into Unity, I said we could change this back to 30, but we aren't done testing yet. So let's change the time to complete question to 5. and we'll keep the time to show correct answer as 10 for now. So if we go ahead and hit play, we should find that it starts counting down from 5, and then when it reaches 0, it'll flick over to 10 seconds, and this will slowly count down. And then when this reaches 0, it'll flip back to 5. So we've now got a nice timer that's flipping back between 5 seconds and 10 seconds. That's pretty much the bones of our timer now working. And in the next lecture, we're going to start paying a bit more attention to the fill image for our timer and calculating the fill fraction. So I'll see you there. In this lecture, we're going to finish off our timer script. We're going to be calculating the fill amount for our timer image, which we'll connect up in the next lecture. And we're also going to add a couple of additional hooks that our quiz script can use to talk to our timer. So let's dive in. So next, let's have a look at the fill fraction for our image. So over on our quiz canvas, if we go down to our timer image, our fill amount is ranging anywhere between 1 and 0. So we want to say, based on the amount of time that we've given our timer, we want to normalize that between 0 and 1 and return a fraction. So let's jump back to our script for a little bit of math. And I'm actually going to change our if statements here just a little bit. I'm actually going to change them around. So instead, what I'm going to do is say, if the timer value is greater than 0, then we want to figure out this fill fraction amount for our timer image. Else, we want to change the timer over and set all our values. So a little bit of a change there, but nothing too drastic. It's just reframing our if statement. And this is just a personal preference thing of mine. So feel free to leave yours as we've had it if you prefer it that way. So on to figuring out this fill fraction amount for our image. At the top of the script, let's create a new variable to store that value. This value is again going to be needed by our quiz script so it can adjust the actual image sprite on our canvas. So let's make a public float. And again, you may want to make this private and add getter methods and things like that. But again, it's a very small game and I'm not too worried about lots of things trying to change this. And I'm going to call this the fill fraction. With our variable set, let's head back down to update timer and figure out what's going to go in this if statement. Well, with a little bit of very simple math, we can just say that the fill fraction is going to be equal to the current timer value divided by, in this case, the time to complete question. To explain this math, so I'm not just giving you code, let's imagine that we have a time to complete question of 10 seconds. And a timer value of 5 seconds. This gives us 5 divided by 10, which would give us 0.5, so a half. So it would be halfway through our time. If we instead change our timer value to say 0, so it's just run out, this would give us 0 divided by 10, which would give us 0. And at the other extreme of this, if we had a timer value of 10, so it's just started, we'd have 10 divided by 10 would give us 1. So our fill fraction has been nicely constrained between 0 and 1, which is what our UI element expects, and everything should work nicely. So with our math done, let's just copy and paste this line and drop it into our other if statement below, so in our else block. But this time we're going to say that the fill fraction is equal to our timer value divided by our time to show correct answer. And to test this out, let's go down to our debug log message here. And let's add a bit more detail to this so we can see exactly what's going on. So let's add the is answering question toggle. We're then going to have our current timer value for that state. And then finally, we're going to add in our fill fraction. So this is just for testing, so doesn't matter how pretty it looks, but hopefully this format should look okay in Unity. So let's save up our script and jump back into Unity to test this out. If we clear our console, let's go ahead and hit play. And if we pause very quickly, we can see here that we are currently in the answering state. The answering state, if you remember, has 5 seconds on the clock. So here, with 3 seconds left on the clock, we're around 0.6 of the way through. And if we carry on playing just a little bit more and let that timer run down, we'll see that as the timer runs down, the fill fraction gets closer and closer to 0. So here, with 0.4 seconds left on the clock, we have a fill fraction of around 0.08. Let's carry on playing to see that tick over. Here we can see the answer state is now false, so we're in the showing correct answer phase of our game. We've got around 9 seconds on the clock and a fill fraction of around 0.9, so almost completely full. So our timer is working nicely. It's correctly changing states when we need it to, keeping track of the remaining time in that state, and also giving us a nice fractional value that we can pass over to our quiz script to update our timer image. There are 2 more things though that we want to do in this timer script, so let's jump back. One thing I'm going to want in here is another public variable which will talk to our quiz script and let it know when it needs to show the next question. So let's create another public bool, and let's call this load next question. We want to set this to true in our timer script, so let's have a think about where this should live. And if we run through the logic, we want to say that if we are not answering a question, so we're going to be in our else block, and the timer has also run out, so essentially where we're setting this is answered question to true and resetting our timer value, we're also going to set load next question to true in here as well. Now you might be wondering why we're not just reusing this is answering question, and that's because we want to be able to set this load next question to false from our quiz script, and it doesn't really have anything to do with the logic of the timer itself. It's purely a hook into our timer script. That will become a lot clearer when we actually hook it up in the next lecture. So for now, just put a pin in that for the moment and we will come back to it. But the last thing for this script is going to be a way of cancelling our timer early. Because once we've answered a question in our quiz, we don't want to have to sit and wait for this full 30 seconds to run out. We want to jump straight to the solution. So let's create another method in here, and this one is going to be public this time so that our quiz script again can talk to our timer. It's not going to need to return anything, so let's make it void and we'll call it cancel timer. This is super simple, so have a quick think and see if you can figure out what this is going to do. And I'm not going to give you too long. All this is going to do is set our timer value equal to 0. So that in our update timer, this will basically just hotwire this timer value minus equals delta time. It'll throw timer value straight to 0, so that when we hit our if statement, it's going to change its state for us. So that is our timer script all set up. Quite a lot of work in this one little script, in this one video. But in the next lecture, we're going to hook it all up to our quiz script and actually see our timer in action on the canvas. So I'll see you there. Now that we've got our timer script all set up, it's time to connect it to our UI. So let's head over into our quiz script and set up some new variables. The first one we're going to need is the image on our UI. So let's create a serialized field of type image, and we'll call this the timer image. And then we're going to need access to the timer itself. So this will be of type timer, and we'll call it timer. Now, before we go ahead and do anything else, we're starting to get quite a few variables here, and they all seem to be related to different areas of our quiz. So to help break things up and make the component easier to use and easier to read in the inspector, I'm going to add some extra attributes here. And the attribute I want is called a header. So we can write header, and then in parentheses, the first one I'm going to call questions, because this one is going to help categorize our question text and our question scriptable object. Now we'll see these in action in just a moment, but for now let's get them set up. So after our question related variables, I'm going to add another header, and this one is going to be called answers. So that will help group our answer buttons and our correct answer index, even though it's currently private. Next, we have a couple of sprites which are related to the buttons. So let's add a header for the buttons. And then finally, we have our timer variables. So let's call this one timer. If we go ahead and save this now to see it in action, let's pop back over into Unity, click on our quiz canvas and scroll down. We'll now see that our component has these added headers in there, which help just break up all of our variables and make them a bit easier to work with. While we're here, let's drag over our timer image into the timer image variable slot. And now let's actually connect this to our timer script. Back over in our quiz script, the first thing we want to do is find a reference to our timer. So down in our start method, we can say timer equals find object of type timer. Next, we're going to go ahead and bring back our update method. So we can say void update. And in our update loop, we want to continually change the fill amount for our image timer. And that is going to be your challenge. I want you to change the fill amount for our timer image every frame. Now, I know we haven't done this before, so you are going to have to do a little bit of investigation work on your own. To help you out, as a hint, we've already worked out the fill fraction in our timer.cs script, so you're going to need to apply that value to our timer image's fill amount. So pause the video now and give that a go. Okay, welcome back. Hopefully you got on okay with that challenge and managed to figure out where all the pieces needed to go. We can do this by saying timer image dot fill amount is equal to the timer dot fill fraction. So congratulations if you managed to complete that challenge. But to test it out, let's jump back over into Unity. And if we go ahead and hit play now, we should find that our timer nicely starts ticking down. And then when it reaches the end, it flips state. And in this case, on our timer component, we've got a time to complete question of 5 and a time to show correct answer of 10. So the time to complete question is moving twice as fast. So let's come out of play mode. And for now, we've kind of finished our timer script. So let's set our time to complete question back to 30. And head back over into our quiz script. Next, we want to check the state of the timer to see whether we need to get a new question or not. So if you remember, over in our timer script, we had this public boolean for load next question. And down in update timer, if we go right the way to the bottom, we were setting this to true at the bottom here when it's time to get the next question. So we're setting it to true at this point. And then over in our quiz script, we want to set it to false. This sounds like a job for an if statement. So let's say if timer.loadNextQuestion. Then we want to go ahead and get the next question. Lastly, in this block, we want to say timer.loadNextQuestion equals false. And that will just reset that boolean in the timer script to stop us getting a new question every frame after this becomes true. Finally, before we go ahead and test, let's go down to on answer selected. And once we've selected an answer, we want to cut the timer short and put it into its next state. So right at the bottom, we can say timer.cancel timer. Now let's go ahead and save this script and jump back into Unity. And for testing, I'm going to shorten my timers somewhat. So I'm going to go with maybe 15 seconds and 5 seconds. And if we go ahead and hit play, we can see that our timer is nicely ticking down. And if we select an answer from the list, our timer automatically jumps into the next state. Once that's run out, we reload the question at the moment and the timer begins again. However, if we wait for this timer to run down, we'll notice there's also a little bit of a bug where if we answer a question while the game is in that state, it will automatically jump to the next question. And in that state, we shouldn't really be allowed to click on any of the buttons, and we should also be getting shown the correct results. So let's come out of play and jump back to our quiz script. And let's think about how we're going to do this. So under our answers header, let's add a new bool, and we'll call this one has answered early. This will then let us check whether we've let the timer run out and should be displaying the answer, or whether we click the button to show the answer. And the other thing we're going to need to do is to change something in our timer script. So let's jump over to that script, and the thing we want to change is the access level to this is answered question. Because we're going to want to know if we're answering a question or reviewing an answer from within our quiz script. Now we could go ahead and write a getter method for this, but I'm going to risk it and just make it public. So with that small change done, let's jump back to our quiz script. And now let's add another check to our update loop. Because we now want to check whether we've answered the question early or not, and what state the timer is in. We can do that in an else if block, so slightly different to the regular else that we've been used to so far. And this just allows us to do a secondary check if the first if statement fails. So in here, we want to check two things. First of all, we want to check that we haven't answered the question early, so not has answered early. We then want to go ahead and ask a second question in here. And we can quite easily ask two questions in an if state by using the conditional and, which is just two and symbols next to each other. The second question we want to ask is going to be not timer.isAnsweringQuestion, or in other words, that we're not in the answering question state. Now, if both of these conditions are satisfied, we're going to want to go ahead and display the answer. And we're currently doing some answer displaying in our onAnswerSelected method. But since this is being called from a button press and there's some other stuff going on like cancelling timers, we're going to want to extract the actual displaying of the answer so that we can reuse it independently of just clicking on the buttons. So let's do a little bit of refactoring next and take all of this highlighted code and create a new method. This doesn't need to return anything, so we can call it void and we'll call it displayAnswer. Just like onAnswerSelected though, this is going to have to take in the index so we can highlight the correct answer. And then we'll just go ahead and copy and paste our code. Next, we're going to need to call this displayAnswers from within onAnswerSelected. And I'm going to pass in the index that we're passing in to onAnswerSelected. This has now nicely separated things out. And with that, we can now go ahead and display our answers in the event that the timer runs down to 0 and needs to start displaying the answers on screen. In addition to this, we're also going to want to set our button states to false. Now we're getting a red squiggly here with our display answers because we need to pass in an index number. And because we're not clicking on any buttons, we don't accidentally want to pass in a potentially correct answer. So we can't really use a number between 0 and 3. So a common practice in this kind of case is to pass in -1. This is still going to work with our display answer because it's definitely not going to match the correct answer index. So we're just going to automatically fall into the else block. Now, finally, we need to start worrying about how to change the state of has answered early. So when we go ahead and load the next question, let's set that has answered early to false at that stage. And then in onAnswerSelected, so if we click one of the answer buttons, we can confirm that we have indeed answered the question early. So let's set that to true. And with that, I think our game is all set up. So let's go ahead and save that and jump back over into Unity. Let's go ahead and click on play. So our timer is still working. And if we click on an answer, it will work and jump through. And if we instead let the timer run down on its own, then we'll also find that the answer is displayed. So everything seems to be working and we now have a nice functioning game loop. But it's still pretty boring with only one question constantly being reloaded. So in the next lecture, we are finally, and I do mean finally, going to be adding our other questions to our game. So I'm very much looking forward to it, and I'll see you there. Okay everyone, it's been a long time coming, but we're finally going to be adding our other questions to our quiz. And to do this, we're going to be using something called a list. So what is a list? Well, they're kind of like arrays, which we've already seen when we were storing our buttons. So if we consider the similarities to an array, a list is still a grouping of multiple variables of the same type. Each item stored within our list is still called an element. Each element can be accessed by its index number, and counting again starts at 0. So they're the similarities, and you may currently be thinking that they're virtually identical. But the big difference between a list and an array is that lists are mutable, meaning that we can change their size. So with an array, once it's created, we can't change the size. But a list, we can add and remove items as much as we like. So let's look at the syntax of how to create a list. If we first consider the syntax for an array, then we can create a new array like this. But for a list, the syntax is slightly different. First, we're going to specify that we want a list, and then inside the angled brackets or chevrons, we're going to tell the list what type it's going to be storing. So in this example, we're storing a list of integers. We then have the name of our variable, which in this case is odd numbers. And then we can initialize this list by saying new list of type integer. So that's how we're going to be creating a new list. But now let's look at some useful methods that are going to come in handy. First of all, if we want to check the item count within our list, we can use list.count. So this is very similar to the array.length that we were using before. Next, if we want to check that an item exists within our list, we can use list.contains, and then we can pass in the thing we're looking for. So with the example of storing our odd numbers, this would ask whether the number 3 currently exists in our list or not. If we'd like to add a new item, we can use list.add and then tell it what we want to add. So in this case, the number 3. We can remove an item with list.remove and again pass in what we want to remove if it exists. If we don't know a specific value that's contained in our list and we just want to remove the item at a given index, we could use list.removeAt and then pass in the index that we're interested in. So in this case, remove at 0 would remove the first element in our list. And finally, another good one to remember is list.clear, which will completely empty our list. So with explanations out of the way, let's go ahead and create our list for our questions. However, before we go ahead and do that, there's one thing I want to change about our current code, and that's our current serialized field for our current question. Once we've created our list, we're no longer going to need this serialized in the inspector. So let's go ahead and clear things up by just removing that serialized field attribute. And the other thing I want to do is actually rename this variable, because our list is going to have a very similar name. And to avoid errors and confusion as we continue to code, let's go ahead and rename this by pressing F2. And instead of question, let's call this the current question. With that renamed, that should have replaced any instance of our old question with current question. So if we have a quick scroll down, we can see that in display answer, it's now looking at the current question instead. And in display question, we're also looking at the current question. So minor code fixing aside, let's go back up to our variables and let's go ahead and create our list. We're going to want to drag over our questions in the inspector. So let's make this a serialized field. And we can create a new list by saying list of type question SO, so our question scriptable objects, and we'll give this variable the name questions, which is why we wanted to change our old question variable to current question. Now, because this is serialized, we can go ahead and leave this as it is, but if you want some added protection in case you remove the serialized field later on in your journey, we can instantiate this list by writing equals new list of type question SO. So with our list set up, and once we've dragged the questions over in the inspector, we're going to need to get questions from this list and make them the current question. So let's scroll down to our getNextQuestion method. And now when we get a new question, we're instead going to want to get the question from our list. Now there are many ways we may decide to get these questions from our list, but to add a bit of randomness to our game, I'm going to be pulling a random question out of our list whenever we need to get a new one. We're going to do this in a new method. So once we've set the button state and the button sprites, but before we display our question, let's go ahead and write a new method called getRandomQuestion. Then we're going to need to write this method. So underneath our getNextQuestion, let's create a void getRandomQuestion method. Let's start by getting that random number. So we're going to have a temporary variable of type int called index. And this is going to be equal to random.range with a minimum of 0 and a maximum of our questions.count. So this is going to return a random number between element 0 of our list and the last element in our list. With that index, we can then say that our current question is going to be equal to the question in our list at that index. And then we want to go ahead and remove that question from the list. So we can say questions.remove the current question. Now this should all be fine, but whenever I remove an item from a list, it's always good to just double check that it actually exists to avoid any potential errors cropping up and just to err on the side of caution. This shouldn't strictly be necessary for our game because it is very small and we're not going to be doing much else with our questions list. But in larger projects, when we start moving things around and we have a lot of things talking to each other, it's always good to make sure this check happens so that we don't accidentally run into a problem that may cause our game to throw an error. And we can check to see that our current question exists in our list by saying if questions.contains the current question, then we want to go ahead and remove it. Now with that set, let's go ahead and save our script and jump over into Unity to test it all out. If we look in the inspector under our questions header, we now have a list of questions that we can use. So let's lock the inspector so that we can drag our questions over. Head over to the questions folder where we stored all of our scriptable objects, and then select all of them and drag them over into our list. Now for me, that's put them in reverse order, but because I'm pulling them at random, it doesn't really matter too much. If you want to change the order of any of the elements, you can just click and drag to move them up or down. And if you want to add or remove any other elements, then we can either use the plus and minus buttons at the bottom, or we can change the size of our list with this input field. So questions all set up, we should now be picking questions at random. So let's go ahead and hit play to test this out. And before we go ahead and answer a question, I'm going to pause the game and click back on my quiz canvas so I can see the questions that are in our list. And we'll notice that 2 of them have actually been removed rather than just 1. Now, the good news is the questions were randomly selected, but why did we remove 2 of them? Well, there's a very logical explanation for this, which we'll fix in just a moment. But for now, let's just do a little bit more testing to make sure that it doesn't happen for every single question. So let's unpause our game and wait for the timer to run down. And for all subsequent questions, it does look like it's just removing the 1. So if we quickly skip through the rest of our quiz, we'll notice that once we've answered the final question and our list is empty, then if we check the console, we're getting an error saying that the index was out of range, i.e. we're trying to pull an item out of a list when the list is empty. So 2 bugs to fix there. So let's jump back over into our script. And the first bug of removing 2 questions at once is incredibly simple to fix, because if we head up to our start method, we're currently getting the next question in start, and we don't actually want to be doing that anymore. So let's delete that line and also our commented outline as well. And that should fix the problem with 2 questions being selected on the first run through. And then to fix the error that comes up when we've run out of questions in our list, let's head down to our getNextQuestion method, and we're going to put in a check here. And I think this would make a very good challenge for you. I want you to go ahead and modify our getNextQuestion method to check whether there are still questions left in our list before we go ahead and execute those other 4 methods. So pause the video now and give that one a go. Okay, welcome back. So hopefully you got on well with that challenge. And the solution to this problem is going to be to use an if statement and ask if the questions.count is greater than 0, then we want to go ahead and run these 4 methods. So let's go ahead and test this out to see if everything's worked. Through the magic of video editing, we can find that both of these bugs have now been fixed. So congratulations, we now have a game with multiple questions, and at this stage you can feel free to add as many other questions to your game as you like. Now the next thing we're going to want to look at in our game is to improve the UI a little bit, because we now have multiple questions, but the player has no idea how far through the game they are. But that's a topic for another lecture, so I'll see you there. In this lecture, we're going to be adding a scorekeeper to our game to track how the player is doing as they progress through our quiz. Okay, so the first thing we want to do before we worry about any coding is to just place some score text on our canvas. So let's go ahead and open up the pre-visualization canvas to see where we want this to go. And I've got mine up in the top left corner. On our quiz canvas, let's right click, go down to UI and then up to our TextMeshPro text element. We can go ahead and drag that into position and roughly resize it. And let's also go and rename our component in the hierarchy. So let's call this the score text. Let's change the dummy text itself to something like score at, say, 100%. And then let's resize it to around 48 points. Change the alignment options. And then go ahead and hide the pre-visualization canvas to see everything together. That looks okay to me for now. So now let's go ahead and create our scorekeeper script. Down in our scripts folder, let's right click and create a new C# script and call this one the scorekeeper. And now let's add this script to an object in our scene. Just like our timer, we could reasonably put it anywhere that feels sensible. And because we've got our timer on a separate object, let's go ahead and create a new empty object and call this one the scorekeeper. Let's reset the transform and drag over our scorekeeper script. And now let's open that script up. Now, when it comes to scoring in a game, there are many different options that you might take. You might want to add a certain amount of points to each question that gets answered. But as you may have already guessed, I'm going to go with a percentage-based system. And for this system, we're going to need to know 2 things. We're going to need to know how many correct answers the player has got, and we're going to need to know how many questions the player has seen to that point. So let's create 2 variables to store these values. These are both going to be integers. So we'll call the first one correct answers, and we'll default that to 0 to start with. And we'll call the second one questions seen. And again, we'll default that one to 0 to start with. Now, for the access level of these 2 variables, we are going to need to see them in other scripts, but rather than making them public and allowing them to be edited at will, we're going to use some getters to protect access, but we're also going to use something called a setter method to help control which values get passed into these variables. So let's go ahead and delete start and update because we're not going to need them. And let's start with the getter, which we've seen in previous lectures. Let's set up the correct answers first. So we're going to have a public int called getCorrectAnswers. And we may actually not need this particular getter, but it's worth having in there for completeness, just in case we change our minds or change how our game works later on. And this method is just going to return the correct answers. Next, we're going to need a setter method, which will control which values we can pass in to these variables. And for this particular game, I'm going to use a setter that just increments the values by 1 every time. So let's create another public method, and this one isn't going to return anything, so we can make it void. And let's go ahead and call this one increment correct answers. And in here, all we're going to do is just say correct answers plus plus. So every time we call this setter method, we'll just increase the correct answer count by 1. So with our getter and setter method set up for our correct answers, we now need to do the same thing for our questions seen variable. And that is going to be your challenge. I want you to create the getter method for questions seen, and I want you to create the setter method for questions seen that increments the stored value by 1 every time it's called. So pause the video now and give that a go. Okay, welcome back. So hopefully fairly simple. For our getter method, we're going to have a public int called getQuestionSeen. And all this needs to do is return question seen. Then for our setter method, we're going to have a public void increment questions seen. And this is just going to take questions seen and add 1. So with our getters and setters all set up, it's time to do a bit of math and work out how we're going to calculate the score. Now for my game, I want my percentage values to be rounded to the nearest whole number, so I don't want any trailing decimals left in my answer. So with that in mind, let's create the method that's going to calculate our score. We're going to want a public method, which returns an integer value, and we'll call this one calculateScore. Now if we think back to math class, to get a percentage value, we're going to want to return the correct answers divided by the questions seen multiplied by 100. However, because our correct answers and questions seen are both integers, unfortunately it's not going to be quite that simple, because whenever we do integer division, the answer will also be an integer. So for example, if we'd answered 3 questions correctly and we'd seen 4 questions, we would expect this to come out at 0.75 or 75%. However, with the integer division that we've got at the moment, this would actually return 0. Now the way we go ahead and fix this is to cast one of these integer values into a float. So let's do that on our questions seen. And the way we cast a variable is to place some parentheses before it and then tell it the type of variable we want it to be. So in this case, we want our questions seen to be a float. In our example, this would now treat our 4 as a 4.0. And now rather than doing integer division, we're now doing floating point division. And so the answer will come back as a float. Now we'll notice this has given us a big red squiggly line. And if we hover over it, it will tell us that we can't implicitly convert type float to an int. And that's because we're trying to return a float where we're supposed to be returning an integer. Now we could go ahead and wrap this entire expression in parentheses and then cast it back to being an integer. But this can get a little messy, and I also want to do some rounding on this. So instead, let's take advantage of the mathf class, which has a lot of mathematical operations available to us. And the one we want for our particular problem is going to be round to int. So this is going to take a floating point number in and then round it to the nearest integer. So let's wrap our expression in the parentheses, and our red squiggly goes away, and this should now work correctly. Let's get rid of our little example comment at the end, save our script, and now let's go ahead and hook it all up in our quiz script so we can see it in action. Let's start by adding a couple of new variables to our list here. So underneath timer, let's add a new header called scoring, and then we're going to need a serialized field of type TextMeshProUGUI, and we'll call this the score text, so that's the text on our UI canvas. And then we're going to need a reference to our scorekeeper, so let's have scorekeeper, and we'll call it the scorekeeper. In start, let's find that scorekeeper, so let's say scorekeeper equals find object of type scorekeeper. And now let's look at incrementing our correct answers and questions seen. So if we scroll down to our display answers method, because that's where we were checking whether we got the right answer or not, in our first if block, if we did get the answer correct, let's go ahead and say scorekeeper.increment correct answers. And then down in get next question, so when we get the question initially, we'll set our scorekeeper.increment question seen. So that takes care of the numbers being incremented. And to show our score on the UI itself, let's scroll back up to on answer selected, I think would be a good place to do it. And we'll set the score text.text equal to score plus the scorekeeper.calculateScore. And to cap that score off, let's also add a percentage sign at the end. So let's go ahead and save our script and jump back over into Unity. On our quiz canvas, let's hook things up. So we need to drag over our score text into the field. And now let's go ahead and hit play and check that everything works. So our score is starting off at 100, which we may want to change later on. But if we get a question wrong, it should go down to 0%. And if we go ahead and get a question right, then we'll see that our score jumps up to 50%. So our scoring system seems to be working correctly. And as we continue to get questions right or wrong, our score will update accordingly. So with that, we now have a fully functioning scoring system, and it's arguably flexible enough that you could potentially reuse it for other games in the future. Now there's one more piece of UI functionality that I want to add to my quiz, and that is to tell the player how far through the quiz they are when they answer a question. So that's what we'll do in the next lecture, so I'll see you there. In this lecture, we're going to be adding the final touches to our quiz canvas by adding a progress bar to show the player how far they are through our quiz. Okay, so to add a new slider to our canvas, let's right click on our quiz canvas, head down to UI, and then find the slider option about halfway down. This has added a very small slider to our canvas, so let's make that a little bit bigger and just move it to somewhere where we can see it. And this particular UI element is a little bit more complicated than the other ones we've encountered so far. So let's have a look at it and break it down. First of all, on the root game object, we have this slider component, and some of these options may look familiar from things like the button component. So we have the interactable toggle, so whether we can use it or not. We have the transitions, so we can change the colors when we click on it and things like that. Or if we click on the drop down, we can do things like sprite swapping. For us, just like our button component, we're not going to worry about any of those, so let's click that to none for now to simplify things down. We've then got some navigation options, which again we're going to ignore. We have a fill rect and a handle rect, and these relate to objects that are children of our slider. So if we look over in the hierarchy and drill down into the children, we'll find the fill object and the handle object. Next, we have a direction. So this at the moment will slide from left to right as we fill it up, but we could equally change this to one of the other options. So we might go in the opposite direction, or we might go from top to bottom or bottom to top. I'm going to leave mine on left to right for now. We then have a minimum and a maximum value. So these are the two values that our slider considers home on the left and right of the bar. So at the moment, our slider will go from values 0 to 1. If we change this to say 5, then we'll notice our 1 is only a fifth of the way through. Next, we have a whole numbers toggle flag. So at the moment, we're in floating point mode, which means we can have values with decimal points after them. But if we enable this whole numbers option, our slider will change from a continuous slider to a discrete slider, so it will only jump up in whole number increments. And this is going to be very useful for our game because we're counting how many questions have passed, so we're only ever going to need whole numbers for this. And finally on this component, we have the onValueChanged event system, which we're not going to be using for our game, but this would work very similar to the onClick event on our buttons. So we can run scripts and code based on when the value of the slider gets changed. So that's the slider component. And now let's look at some of the children contained within this, because there are really 3 layers to our slider. We have the background element, which really is just a simple image component. So we can do things like changing the color or changing the background sprite. And underneath that, we have the actual fill image. And just like the background, this is just another image component that sits on top of the background. So again, we can just go ahead and change the colors to whatever we like. And finally, we have the handle slide area, which contains the handle image. And again, this is just a normal image component that sits over the top of the other 2. So we can again do things like changing the color. Now, when it comes to using sliders, we don't always want this handle to be present. It's fine if we're using the slider as an actual slider and need to drag the values up and down to say set volume levels or things like that in a settings menu. But sliders are also very good for things like progress bars and health bars. And because the background, fill and handle are all really just images, we can quite happily go ahead and hide them in the inspector and not change any of the functionality of the slider itself. So since all of the components of a slider are really just images, let's go ahead and set up the slider for our game. And that is going to be your challenge. I want you to set up the progress bar on the quiz canvas. So think about resizing and positioning your slider wherever you like on the canvas. Change the background and fill colors or sprites for your slider, and set up or disable the handle. So pause the video now and set that up. Okay, welcome back. So before I go ahead and position things, I'm going to re-enable my pre-visualization canvas. And you can see that I've originally designated our progress bar to sit at the bottom of the canvas. So let's go ahead and take our slider and reposition it. I'm just going to drag it down and then resize it so it's long and thin. I can then go ahead and hide our pre-visualization canvas and do a final piece of movement. So I'm just going to raise it up just a tiny bit. Next, I don't think this red and purpley blue color scheme is working for me, so I'm going to go on the background. I'm going to change the background color to white and maybe lower the opacity to around 0.5. And I'm also going to change the source image from the background square image to our neon square image. And finally, I'm going to change the fill to again use our neon square blue sprite, but this time I'm just going to tint it to be a lighter blue. So with our slider all set up on the canvas now, let's go ahead and hook it up to our quiz script. So the first thing we're going to need is a reference to our slider object. So let's go ahead and add another header for our variables, and we'll call this one the progress bar. And then we're going to need a serialized field of type slider, and we'll call this the progress bar. With that set up, we now need to think about how we're going to update our slider. And there are many ways to do this, but since ours is going to be working in discrete steps, it would make sense to set the slider's maximum value to the number of questions in our quiz. And then for every question that we show the player, we can just increment the slider's value by 1. So in start, let's set our progress bar's maximum value by writing progressbar.maxValue. And we'll set this to the questions.count. And we're also going to want to set our progress bar dot value to 0. So that just sets up our starting value for our progress bar. And then when we go ahead and get a new question, so let's scroll all the way down to get next question. In here, we're going to want to increment our slider. Now we could go ahead and write a new method for this, but since it's just a single line of code, I think we can be forgiven for writing it directly in this method. And we're going to say progress bar dot value plus plus. Now, one last thing I want to do before testing this out is actually to use this progress bar to indicate when we've reached the end of the game. So let's head all the way back up to our variables and add one last public variable. And this is going to be a Boolean called isComplete. And this variable is just going to store the state of whether the quiz is still in progress or whether the player has completed the game. And to set this flag, we're going to head down to onAnswerSelected. And in here, we're going to say that if the progress bar dot value is equal to the progress bar dot max value, then isComplete will be true. And we know this will be the case because our progress bar will be incremented when the question is shown. So on the very last question, by the time we've submitted our answer, the progress bar and max value should match. So let's go ahead and save that and head back into Unity to test our new feature out. Let's go over to our quiz canvas and connect that slider up. So let's drag down our slider into the progress bar. And let's go ahead and hit play. We'll see that our progress bar is around 1/5 the way through because we're on our first question. And as we go ahead and answer our questions and have new ones presented, our slider bar will continue to go up. If we just spam through the rest of this quiz very quickly, then once we're on our last question, we'll notice the isComplete flag isn't checked yet. But once we answer our question, the game is now completed. And we're going to use that fact in the next lecture to display a whole new end screen canvas and reload the level if the player wants to play again. So I'll see you there. Our game is now mostly working. But when we get to the final question, the game just seems to stop. So in this lecture, we're going to finish off the experience with a win screen that will show the player their final score and also give them the option to play again. We're also going to be fixing a minor bug that we left in the last lecture, which is all to do with our slider. Because at the moment, the player could, in theory, click on the slider and change the value to whatever they like, potentially ending the game early. So let's fix our slider bug first. So over on the quiz canvas, let's go down to our slider. And it's really just as simple as changing this interactable toggle to be off. This will prevent the player from being able to interact with it, and it will now only move based on the code that we've written for it. So with bug fixed, now let's think about our win screen. So for now, I'm going to hide my quiz canvas. I'm going to re-enable my pre-visualization canvas. And because we're now done with our core game screen, what I'm going to do instead is on the image, I'm just going to drag over the end screen pre-visualization that I've got here. So pre-visualization set, it's now time to create our win screen canvas. And that is going to be your challenge. Using all the knowledge that you've gained in this section so far, I want you to set up your new win screen canvas in the hierarchy. On this new canvas, I want you to add a text field that we can use to display the final score. And I also want you to add a button so that the player can choose to reload the game if they want. Now we're only worried about setting up the UI elements at this point and not the code that drives it all. So pause the video now and give that a go. Okay, welcome back. So let's set up a new canvas by right-clicking in the hierarchy, going to UI and then Canvas, and we'll call this the Win Canvas. Now, before I go and add any other elements, the first thing I want to do is go over to my Canvas component and just change the sort order to 2. This will then make sure that it always appears above our quiz canvas and also above our background canvas. Next, let's go ahead and add some text. So right-click on our Win Canvas, down to UI and then up to TextMeshPro. Let's roughly drag it into position. Let's set some dummy text to maybe congratulations, you scored, and then a default score %. Then we'll change the font size and we'll make this maybe 65. And we'll change the alignment options to middle and center. With that set up, let's also give it a half decent name in the hierarchy. So let's call this the final score text. And finally, let's add a new button. So right click on our Win Canvas, down to UI and then up to Button TextMeshPro. Let's call this the replay button. Drag it into position. And for this button, I'm going to change the source image. So over in our sprites, I'm going to drag over the neon orange square. And rather than directly following my pre-visualization, I think I'm going to make it a little bit shorter and a little bit fatter. Let's quickly center that. And then down on our button component, we don't need the color transition, so we'll clear that off for now. And we will be setting up the on-click later on. We drill down into the text object on the button. Let's go ahead and change the text to play again. Let's set the font size again to around 65. And I'm going to change the vertex color to be pure black. So with our canvas now set up, let's go ahead and hide our pre-visualization canvas. And I think that's not looking too bad. The last step is to tidy up our hierarchy a little bit. So I'm going to drag my Win canvas to be underneath my quiz canvas, so that all of my canvases are together. And I'm also going to go ahead and delete my pre-visualization canvas because I'm no longer going to need it. Okay, so hierarchy all tidied up. It's now time to write a script for our canvas. So just like we had the quiz script in our quiz canvas, we're going to have a script that controls the elements on our Win canvas. So over in our scripts folder, let's create a new script. And let's think about a name. Now, I don't think Win is a particularly good name for a script, so I'm going to call this the endscreen.cs. Let's drag that over onto our Win canvas, and then go ahead and open it up. In this script, we're not going to need our update method, so let's clear that out of the way. And also get rid of our comment above the start method. We're not really going to need access to the button on the canvas, but we will need access to the text field. So at the very top, remember we need to include a using statement for our TextMeshPro field. So using TMPro. And then inside the class itself, we can add a serialized field of type TextMeshProUGUI, and we'll call this the final score text. And since we're going to need to display the score, we're going to need access to our scorekeeper. So we'll call that scorekeeper as well. Down in start, let's find the reference to that scorekeeper. So we can say scorekeeper equals find object of type scorekeeper. And finally, let's create a method to update the final score when the end screen is shown. Now, there are a couple of good ways to do this, but I'm just going to use a standard public method, which we're very familiar with, that we can then later call from another script. So let's call this a public void show final score. And all this needs to do is update the final score text.text to be equal to our congratulations message. So congratulations. Then we'll add a new line character. So the second part of our message will appear on a second line. And finish it off with you got a score of our scorekeeper.calculate score. Let's also consider adding our final percentage sign there as well. And because this line is very long, let's hide our sidebar. And also let's just break this onto a second line. And because C# doesn't care about white space, this is absolutely fine to do. The only real caveat is that it needs to be broken in the right place. So here we're adding something to our string, so it's a good place to break on this line. If we broke in the middle of a string, then we'd definitely get some weird errors. So as long as you're careful about where you decide to break your lines, the compiler really won't care that much. Let's go ahead and save our script and jump back over into Unity. Then on our win canvas, let's scroll down to our end screen script and just drag over our final score text. With that set up, unfortunately, we're not currently in a state where we can really test it because we're still lacking the key component that will switch between our quiz canvas and our win canvas. So in the next lecture, we're going to finally finish up our game by adding in a game manager, which will do all of that work for us and also allow us to reload our game. So I'll see you there. In this lecture, we're going to be creating the game manager, which is going to control the flow between our quiz screen and our win screen, and this will mark the end of our project. So let's go ahead and create our game manager. Over in the hierarchy, let's right click and create a new empty object. I'm just going to reset the transform and then rename the object to be the game manager. And let's go ahead and create a new script in our scripts folder. So right click, create C# script, and call it the game manager. And you'll notice with this script, it's been given a brand new icon. And that's because game managers are incredibly common. So Unity has kindly changed the icon for this type of script so that we can easily find it buried in our assets folder. Let's go ahead and drag our game manager script over to our game manager object. And then we're going to go and open that up. Now, before we worry about reloading levels and things like that, let's just set up the transitions between our quiz canvas and our win canvas. So let's go ahead and tidy up the comments above start and update, but we are going to need both of these methods, so we'll leave them intact for now. Up at the top, we're going to need a few variables. We're going to need access to our quiz script, so we can say quiz and we'll call it the quiz. And we need access to our end screen script, so we'll call this the end screen. And in start, let's go ahead and find both these objects. So our quiz is going to be equal to find object of type quiz. And our end screen is going to be equal to find object of type end screen. Next, we're going to want to toggle the visibility of these canvases so that our quiz canvas is visible when the game starts and our end screen is hidden. And then later on in the game's life cycle, these will swap over. So also in start, let's say that our quiz.gameObject.setActive equals true. And our end screen.gameObject game.setActive equals false. So what this is doing is taking the game object itself and then changing its active state in the hierarchy. So if we jump back to Unity, it's just like toggling the little flag next to the name up in the inspector. So if it's true, we can see it, and if it's false, it'll disappear. While we're here in our hierarchy, let's enable both our quiz canvas and our win canvas. It makes things look a bit messy, but that's okay, because if we go ahead and hit play, then our game manager is going to sort everything out for us, and it's going to enable our quiz canvas and disable our win canvas. Next, our game manager is going to want to toggle the states for our two canvases when the game ends. So back over in our script, we're going to do this in update, and this is going to be your challenge. I would like you to check whether the game has been completed. And if it has, then we want to disable the quiz canvas and enable the win canvas. So pause the video now and give that a go. Okay, welcome back. So to check whether the game is completed, we're going to need an if statement. And if you recall, in our quiz script, we have a public variable called isComplete. And this was being set when the progress bar was completely filled. So if our game is complete, we want to take our quiz.gameObject and change the setActive to false. And we want to take our endscreen.gameObject.setActive to true. Finally, for this method, we're going to want a way of reloading our scene if the player clicks the Play Again button. And we can do this using the Unity scene management system. So at the top of our script, let's add another using statement. And this time we're going to use Unity engine.scenemanagement. We can then create a new method that we can attach to our button. So let's create a public void, and we'll call this onReplayLevel. And to reload the scene, we want the scene manager.loadScene, and in here we have a multitude of options. And if we scroll through, we're going to use this option here where we pass in the scene build index. And to get the build index of the current scene, we can say scene manager.getActiveScene.buildIndex. So this is getting the build index of the currently active scene, and we're just telling the scene manager to load that scene again. That will refresh our quiz and all of our scores and allow the player to play the game again. So let's go ahead and save our game manager script, jump back into Unity. And on our win canvas, we want to go to our replay button, scroll down, and in our onClick event, we're going to add the plus icon, drag over our game manager, and then in the drop down, we're going to select the game manager and then onReplayLevel. Now it's finally time to test everything out and check that everything on our game is working correctly. So let's go ahead and hit play. And we find that after we've answered all of our questions, our win screen is popping up and our quiz canvas is being hidden, but our score message has not been updated. And that is because we've forgotten to call the method that does that. But while we're here, let's at least double check our Play Again button, and the game does seem to reload. But we've also got a warning message down here, and it's saying we've got a problem with our display answer on line 78. So let's look into both of those problems. Head over into our game manager script first, because when the game is completed, as well as setting our end screen to be active, we also want to take our end screen.showFinalScore. That should update that text field for us to show us our final score. And for the error that's showing up when we reload the game, let's head over to our quiz script. And the problem exists in our update method, where we're currently checking to see if we should be loading a next question. And if we are, then we need to get the next question. Otherwise, we're going to be displaying the answer and setting the button states. And this error is popping up because on the very first update loop of the game, this statement is currently false and this statement is true. So we're trying to display an answer, but we haven't actually set a current question yet. Now this bug can take a little while to track down, but I found the quickest and easiest way to fix this problem is to go up to where we're creating our has answered early Boolean check, and just setting this to true to start with. This means that on the very first loop, if we head back down to our update loop, this check is going to fail. So we're not going to try and display an answer. Then on the next update loop, this will be true and everything will work as intended. While we're here, you may have also noticed during testing that when we answer the final question, rather than giving us time to check the answer, it just jumps straight to our win screen. And this is to do with where we're setting our isComplete flag. So we're currently doing it when we select the answer, which is automatically throwing us to that win screen. So if instead we cut this out of here for now, and what I'm going to do is I'm going to pop it in my update loop when we check for a new question. So now when we answer the final question, we're going to wait for that timer to run down so we can review the answer. And then in update, it's going to try and load a new question, which isn't going to exist in our list, but we're going to catch that with our if statement. We can set isComplete to true, and then to avoid getting another question and potentially causing an error, let's just return out of our update loop early. Finally, before we test everything out for one last time, there's also another bug that you may see. And it's again a null reference exception error, and this time it's to do with the end screen. But since this bug can show up all over the place, let's tackle it on all of the scripts we've written. And the problem comes from finding objects in Start. Now to explain this further, let's have a look at the Unity script execution order. We already know that Start will be called when the game starts and before the update loop. But as you can see from this flowchart, there's also a few more options that are available even before Start. And the method that we're interested in here is the awake method. Just like Start, awake is only ever called once for the lifetime of the game object. And it's good practice whenever we're finding objects in our scene or getting components set up for our scripts that we do these things in awake, because all of the scripts will run their awake method and then call their start methods. So if we jump back over into our script, what we're going to do is whenever we're finding objects in Start, we're just going to change our start method to awake. So in our end screen script, we're going to change Start to awake so that our scorekeeper can be grabbed nice and early. In our quiz script, we're doing some other stuff like setting up progress bars, but because these are related to the quiz script, it doesn't matter if these also happen in awake. So let's go and change our start method to awake in here as well. In scorekeeper, we don't have a start method at all, so we can leave that as is. In our game manager, we're finding some objects of type and setting things to active. And this is a situation where a start and an awake method will come in useful. So above start, let's create an awake method. In awake, we're going to cut and paste our finding objects of type. And then in start, we're going to set whether these objects are active or not. So with that aside on script execution order out of the way, let's go ahead and save all of our scripts and jump back into Unity. Let's go ahead and hit play. We can once again see that our win canvas is being hidden. And if we go ahead and jump through our quiz very quickly, we'll find that our quiz canvas becomes hidden after answering the last question, and our win canvas becomes active. Our score is correctly being updated and displayed. And if we go ahead and play again, then the game will reload and we'll get no errors at any stage during our game. So that now brings us to the end of the section and we now have a working game. The only thing left to do is to add as many questions as you want and give yourselves a big pat on the back for finishing your Quizmaster game. Congratulations on making it to the end of this section. You now have a fantastic little multiple choice quiz game that you can play around with. During this section, we've learned a lot more about the canvas and all the elements that we can add to it, including setting up TextMeshPro, adding buttons, sliders, and images. On the code side, we've learned how to store data using a scriptable object, and then use that data in code with things like lists, arrays, and for loops. We've also learned how to reload the scene when we get to the end of our game, and we're going to be expanding on that in later lectures so that we can have multiple scenes in our games. And the next step is going to be to either continue working on your quiz game by either adding more questions, changing up the scoring mechanics that we implemented in this section, or you could go ahead and try adding a new canvas and adding multiple categories of questions. Once you're done, don't forget to share your game with the community and with other people so they can playtest and give you feedback. And you can do that on sharemygame.com. But once you've finished and you're happy with your final product, go ahead and move on to the next section of this course.
Subscribe now and press the bell icon. Never miss any update.